Okay, well, welcome. For those who just arrived, you can sit for in this part of the sitting arrangement as well. We still have seats over here. Okay, I guess we can start. Okay. Good morning, ladies and gentlemen. Welcome to the grand ceremony and seminar on research finding assisted by the Asahi Glass Foundation 2025. To begin with, it is my great honor to extend a warm welcome to our guests from the Asahi Glass Foundation, Senior Executive Director Dr. Naoki Sugimoto, Director of Research Grant Mr. Hiroshi Usui, Director for Research and Innovation from Institut Teknologi Bandung, Professor Dr. El Fahmi, SSI, MSI, all ITB officials and participants. There will be two presentation sessions in today's seminar. Between the sessions, we will have the poster sessions at the gallery, followed by the opening ceremony of the grant presentations. Ladies and gentlemen, it is now my privilege to invite the Director for Research and Innovation of Institut Teknologi Bandung to deliver the opening remarks and to officially declare the seminar open. Please join me in extending a warm welcome for Professor El Fahmi.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everyone. On behalf of rectors of ITB, I would like to welcome you all in the grand ceremony on seminar on research finding assisted by Asahi Glass Foundation 2025, especially for our guest, Dr. Naoki Sugimoto, Senior Executive Director of Asahi Glass Foundations, Mr. Hiroshi Usui, Director of Asahi Glass Foundations, and unfortunately, some of our colleagues from Asahi who have planned to come could not join us today. Allow me to say some name right now. Mr. Takuya Shimamura, right? You're the boss of them. The chairman of Asahi Glass Foundations, Mr. Manpei Chiyoda, president of PT Asahi, Asahi Flat Glass Tobacco, or Mr. Haruhiko Hishimoto, president of PT Iwake Glass Indonesia, Mr. Takuya Miyagawa, manager of AGC from Singapore, and also Dr. Kyoko Yamamoto, Executive Director of AGC Asia Pacific, and Mr. David Yap, also Manager of AGC Asia Pacific as well. We are very sorry for that. Of course, honorable are the lecturer and researcher from ITB, especially the speaker, and all participants, ladies and gentlemen. I would like also to apologize that our rectors, Prof. Tata Cipta Dirgantara, could not join us today. I heard that he is visiting university abroad right now, but he's sending the warm welcome to you of all for this seminar as well. I really am happy to be here together with you to have the very nice seminars, and we know that Asahi really have a big commitment to support the research from ITB. I noticed that Asahi have provided the research funding to ITB researchers since 37 years ago, from 1988, even I'm not in the university yet at the time. So every year, Asahi give the research funding to ITB researchers, and it also really very prestigious research funding at ITB. I know that this year, 89 proposals have submitted for the Asahi, and only 14 recipients got this funding. Just give applause to them. Some of them are also here. So therefore, today we are really getting pleasure to be together with you to listen presentation from our recipients last year. So I think also 14 speaker, and I believe that those speaker, 14 speaker, will present it very good results. And then we know that maybe with the support of Asahi, of course, also increase that our achievement of research achievement, especially for our publication. And not only publication, actually, what we also expected is some impactful research. Yeah, maybe last time they got the funding from Asahi, and right now those research have been continued by the other funding, and then maybe also produce something that can be used by population, by Indonesian for our development as well. Well, therefore, I would like to again thank of you for your coming today, and I believe for those today seminar we will have the fruitful meeting, and we can learn from the very, very broad, actually broad field of research that we can have knowledge about each topic that can be presented. Of course, I would like also to thank the committee who have presented this, prepared this seminar. And actually, a few days ago, we are worried to arrange an offline meeting, but alhamdulillah, fortunately, we can do it here together, and many participants also doing this one. So we are happy to have this seminar. And this afternoon, we have also the grand ceremony for the new recipient for the Asahi research funding, and also 14. They are also attending is here. So I also thanks to all of you that we can learn for this seminar today. I think that's all what I would like to say, and just to say Bismillahirrahmanirrahim, this seminar officially open. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Bapak. Ladies and gentlemen, we are deeply privileged to now receive word of wisdom from the Senior Executive Director of Asahi Glass Foundation. Please welcome Dr. Naoki Sugimoto.
Thank you very much for your kind introduction. And first of all, thank you very much for joining today, everyone. And also thank Professor El Fahmi for the kind opening address as Direktur Riset dan Inovasi ITB. Saya Naoki Sugimoto, Direktur Executive Senior Asahi Glass Foundation. Am I correct? Okay, thank you. It is truly an honor for me to have the chance to speak at the opening of this seminar. Thank you very much. The Asahi Glass Foundation began this grant program in 1988, as El Fahmi mentioned. Since then, the foundation has supported 380 topics. I understand that the Indonesian government places science and technology at the core of economic development and national strength. I believe the research supported by this grant program is in line with this very important vision in Indonesia. When I look through the agenda and also papers for today's seminar, I was impressed by the diversity of the topics. We will hear about material science, chemical engineering, and bioconversion. We will also learn about thermal engineering, biomaterials, sensing and algorithms. And the program even extends to human environment studies, water reuse, disaster mitigation, tourism, and corporate strategy, very diverse topics. This wide range clearly demonstrates how science and research are deeply connected to our lives and to the future of society. I'm very much looking forward to learning from the valuable findings that will be shared today. We hope that all these research topics, research efforts, past, present, and future, will serve not only to Indonesia, but also all over the world, advancing the technology, strengthening the economy, and protecting the environment. Thank you very much. Terima kasih banyak.
Ladies and gentlemen, moving forward, we shall commence the morning seminar sessions on advanced materials and environmental biotechnology for sustainable development. But first, let's watch this video. Maybe we can play this a little later. Big round of applause. Wow. Such a journey with Asahi Glass, yeah. Okay. Well, now that I have a better mic. Okay, so the following research grantees are going to present their papers. And this seminar session is again on advanced materials and environmental biotechnology for sustainable development. So, Dr. Indra Noviandri MS from the Faculty of Mathematics and Natural Sciences, and then Dr. Grand Prix Tomries Martkaja MSI from the Faculty of Mathematics and Natural Sciences, who will be represented by Dr. Ainul Magfirah, Dr. Attar Lukman Ivansyah SSI MSI from the Faculty of Mathematics and Natural Sciences, Azania Fibriani SSI MSI PhD from the School of Life Sciences and Technology, Mairina Firdayati SSIMT from the Faculty of Civil and Environmental Engineering, Dr. Eng Insinyur Firman Bagjajuangsa STM Eng from the Faculty of Mechanical and Aerospace Engineering, and Dr. Maria Apriliani Gani from the School of Pharmacy. This session shall be graciously guided by Dr. Isa Ansori STM Eng PhD from the School of Electrical Engineering and Informatics ITB. With the highest respect, we now entrust the session to Dr. Ansori. Can I have a big round of applause for Dr. Ansori?
Assalamualaikum. Okay. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the introductions. And then I'm also very glad to be the moderator of the morning sessions from the Asahi Glas Foundation's research grant. And I think we can start it. The first presenters from Dr. Indra Noviandri from FMIPA. Yeah, please give a big round of applause. Just for the informations for the presenters, the presentation time is maximum like 10 minutes. Yeah, so that we have 5 minutes for the question and answer. Bapak, di sebelah sini saja, Pak. Sini aja. Oh iya dah.
Oh, oke.
Biar mudah mobilisasi.
Yang ngatur siapa? Oh, dari sini. Ini bukan dari sini. Bapak boleh. Saya kok. Oh, dari sini aja kita pakai sampai. Saya mau balikin gimana? Balik. Oh, ini. Good. Good morning, everybody. I'd like to present I like to I hope our research finding. This is the title, our research. So actually, in this research, we are trying to find an applications in chemistry of the chemicals we find in lamb toro.
In Indonesia language, we call it petai Cina. Okay. It's normally used as animal feed, or sometimes we also use it as a food supplement in Indonesia. So we try to extract the chemicals in the peel waste of the lam toro fruit, and then we use that extract to reduce silver ions to become silver nanoparticles. And we try to see the functions of this nanoparticle in terms of bacterial inhibitors and the use of this nanoparticle as electrode modifier for glucose sensor. So the peels of the lam toro fruit has been proven to have antioxidant activity and also have a function as antibacterial agents. Okay, so then the extract was tested at, for its phytochemicals, and then we use GCMS to see what other components exist in the extracts. Because it functions as antioxidants, it can reduce silver ion to produce silver, and the chemicals in the extract stabilize the colloid in the form of silver nanoparticles. So we characterize the nanoparticles and checks its function as the antibacterial activity, its function as antioxidants, and its functions of the modifier for glucose sensor. Okay. Qualitative analysis, we found that the extract contain alkaloid, flavonoid, terpenoid, and tannin. We believe that this compound play the main role as antioxidants in the extracts. We also check the other main component, but the main component of the extracts looks like doesn't have antioxidant activity. So then we check the properties of the nanoparticles. Yeah, we found that the nanoparticles stable for 9 months. Okay, so the stability, the stability of the nanoparticle is very good. So we are optimistic that we can use this nanoparticle for many application. Okay, this is the image of the nanoparticle in spherical, and then it has the average diameter of 78.31 nanometers. Okay, and it's stable for 9 months. Okay, this is the test for antibacterial activity. We check the antibacterial activity of silver ions, lam toro extract, and the nanoparticles. We found that from the inhibition zones test for E. coli and S. aureus, silver nanoparticle have the largest inhibition zones. It shows that it is a better antibacterial compared to silver iron and lamtoro extract. We also test with the MIC test and MBC test. Silver nanoparticle still have antibacterial activity even after 1,000 times dilution. Compared to silver iron and lamtoro, it has the antibacterial activity just until 100 times dilutions. Okay. The antibacterial activity of silver nanoparticle is also superior compared to silver iron and lamtoro extract from the MBC test. So it seems that there is a additional activity, antibacterial activity when silver nanoparticles and the lamtoro extracts combine together. And then we check the antioxidant activity of the nanoparticles. We compare it with the normal with the ascorbic acid as a normal antioxidants as a positive standard, and we see the silver nanoparticle has a superior antioxidant functions compared to ascorbic acid. And finally, we applied the nanoparticle as a modifier for glucose sensor. So we electrodeposit the nanoparticle on the carbon paste electrode using cyclic voltammetry technique, and it shows electrocatalytic activity in the oxidations of iron 2 plus and iron 3 plus. And then we use the modified electrode for glucose sensing. This is the result. It's interesting. This is the oxidation peak of silver nanoparticles. When we add glucose, the current decrease significantly, and the decrease increase as the concentration of glucose increase. And we can see the decrease of the currents are proportional with the concentrations of glucose. So it indicates that silver nanoparticle is potential as modifier for glucose sensor. This is still in the initial stage of the sensor developments, but we will continue our research to find the optimum conditions for the sensor. So in conclusions, we can make a nanoparticle from the extract of lamtoro, and it has antibacterial activity and antioxidant properties, and it has potential for electrode modifier for the non-enzymatic glucose sensor. Okay. So finally, I thank to these three students that helped me to do the experiment. Two of them has already graduated and got their PhD degree, and I'm waiting for the other one to get the degree. Thank you very much for your attention.
Thank you very much for the interesting speech and presentations. I also would like to invite the questions from the audience. Yeah, one or two questions, if anyone. Okay. You would like?
Thank you. Thank you very much for your presentation. My question is, can you control the average size of average size of nanoparticle of silver or distribution of the particle, assuming the effect of antibacterial or glucose sensing.
Thank you. Uh, in this study, we are not yet study the effect of the concentrations of uh, silver ion when we make the nanoparticle. But I believe we can control the size and the distributions by varying the concentration of silver ions that we can use. Yeah. Okay.
Okay, maybe I have a short questions.
Oh,
Yeah. So I'm interested with the data that you show using the for the storage. Yeah. So in that case, if the I mean,
Which one?
yeah, no, with the storage, yeah, with that
Oh,
the
okay,
gradually,
okay.
yeah, oh, yeah, for
Okay.
this one. So this one, the silver nanoparticles is initially synthesized and then just keep it inside the storage place, and then yeah, you measure within the several times.
Yeah.
Is it something like that?
Yeah.
Yeah. So what makes this absorbance is changing over the time and then saturated? Do you have some idea, I mean, or
Yes.
explorations? Yeah.
We can see here the 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 peaks, the peaks, the wavelength of the peaks of the spectrum is 420. By time, uh, it's shifted to a little bit lower number. Okay, uh, it suggests that there's some changes of the size into smaller size, but unfortunately we haven't checked that yet due to the dielectric environments, the dielectric property of the environment, and then the size cannot become smaller anymore. That's make it
Saturated.
saturated
Ah,
and step
I
out.
see, I see, I see. Okay, so but this one is very interesting as the size finally can saturate it into some size.
Yeah.
Yeah, is it right? Okay. Yeah. Maybe if we have find some chemicals or reagents that can stop the uh, formations of the nanoparticles, then we can get the exact size in the beginnings. Yeah, not waiting until the storage time.
Yeah.
Probably like
Yeah.
this one.
Okay.
Okay. Yeah. Okay. So I think for the presentations from Dr. Indra Noviandri, yeah, please give the big round of applause. And then we are going for the second presenter from Dr. Ainul. Yeah, Ainul Makfira, representing Dr. Grand Prix Thomas Tomres Mata Karja.
Okay. Hello, everyone. Thank you so much for giving us opportunity to share our finding on the development of gold nanoparticles decorated nanoporous silica fabricated through synergetic combination of pluronic surfactants as an efficient catalyst in the reduction of p-nitrophenol. Okay, p-nitrophenol is an aromatic compound that has been widely used in some industries, including pesticide, plastic, and pharmaceutical industries. However, this compound is also considered hazardous because it is highly soluble in water and has carcinogenic properties. So when it's released from the industrial effluents into the aquatic environment, it will easily dissolve and contaminate the water, which can cause severe health issue due to the carcinogenic characteristic. Therefore, scientists try hard to convert this p-nitrophenol into another less toxic material. And in this case, p-nitrophenol can be converted into p-aminophenol, which is less toxic through a reduction process in the presence of catalyst. Catalyst in this case can facilitate the faster reaction and more efficient conversion of p-nitrophenol into the p-aminophenol. Therefore, choosing the right catalyst in this case is crucial. Generally, the catalysts used for these reactions are precious metals such as rhodium, palladium, platinum, silver, and gold nanoparticle. And among these catalysts, gold nanoparticle is very popular due to the high catalytic performance. However, gold has limitation. Gold nanoparticle is easily agglomerate, and this agglomeration can decrease the catalytic activity of the gold nanoparticle. To address this issue, we can distribute the gold into a support material. This material will support the gold to be more stable, so they don't need to agglomerate each other. So the catalytic performance can be maintained. And in this study, we developed a catalyst based on nanocomposite containing gold nanoparticle and nanoporous silica. And the nanoporous silica here is used as the support material for the gold. Before we synthesize the catalyst, we prepared the nanoporous silica using pluronic surfactant. Pluronic surfactant are 3 blocks of copolymer of polyethylene oxide, polypropylene oxide, and polyethylene oxide. There are two types of surfactant we use in this study. They are P123 and F127. These two surfactants are distinguished by the length of the polypropylene oxide, which is F127 has a longer polypropylene oxide monomers. And then we studied the effect of these two surfactants in the formation of nanoporous silica because it will affect the catalytic performance of the synthesized catalyst. And the successful synthesis of this catalyst is confirmed using several characterizations. First, from the FTIR spectra, we can clearly observe the silicon bonding, COC bonding, which confirm the presence of silica. And then for the gold nanoparticle is confirmed by the surface plasmon resonance phenomenon using UV-Vis DRS spectra. Meanwhile, for the nanoporous structure, we confirm using the N2 absorption-desorption isotherm. And if we see here that all the sample shows the same isotherm profile, and this isotherm profile are typical for the nanoporous materials. And we further characterize the pore diameter using this data. And we got that when we only employ F127 surfactant, we got one type of pore diameter in around 7 to 20 nanometers. But when we also employed the P123 surfactant, we got two type of pore diameter, smaller diameter at around 4 to 6 nanometers. And we further characterize the pore characteristic using TEM imaging. Here, maybe I should explain the label of the sample. Here, NS stand for nanoporous silica, and the first number correspond to the mass of the P123 surfactant, and the last number correspond to F127 surfactant. And if you see here, there are there are two regions, the dark region and the bright region. The dark region correspond to the wall of the silica. Meanwhile, the bright region indicate the presence of void, or in this case is nanoporous structure. Yeah, we can see here that all the synthesized catalyst or the synthesized nanoporous silica shows the bright areas which confirm the porosity of the nanoporous silica. And when we incorporate the gold into the nanoporous silica, some part of the nanoporous silica become turn into dark. It means that we have successfully embedded the gold nanoparticle into this nanoporous silica. And we also saw the observe the effect of the mass ratio between the P123 and F127. We observe that the increase in P123 surfactant result in less ordered nanoporous structure. This occurred maybe because the F127 surfactant has a longer monomers, so it will give different steric stability, where the longer chains will result in more ordered structure, yeah, compared to the shorter one. Here we evaluated the catalytic performance. I'm sorry, maybe we cannot see the visualization, but here the P-nitrophenol is slightly yellow color, and in a basic solution, it transforms into its ionic form with the more instant color, yellow color, and after the reduction process, the color diminishes and transform into a clear, colorless solution. Yeah, it's from this visualization, and we also analyze the UVV spectra. I think we make a mistake. I'm sorry here. This peak correlate to P-nitrophenol ion. Meanwhile, this peak below 300 nanometers belongs to the product, P-amino phenol. And we can see here the PNP ions by the time gradually reduce. And yeah, after in maybe only in 2 minutes, here we got a new peak which correspond to the P-aminophenol. These results suggest that the reduction has been successfully done. And then we studied the effect of the all the synthesized catalysts, and we toward the conversion efficiency, and we got the same pattern, but they give different catalytic performance, where from this result we got that the catalyst synthesized with only a P123 surfactant give the most efficient catalytic process. Therefore, in the next experiment, we use this catalyst EUSN10. And from this data, we can study the kinetic of this reaction, and we apply to one of common kinetic model, that's pseudo first order kinetic, and we got the data is very linear with the R square value quite high, more than 0.96. So we assume that this reaction is very consistent with this model. And we also studied the effect of the temperature reaction to study the thermodynamic aspect. And we got this as the temperature reaction increase, the conversion of PNP into P-aminophenol increases, which mean This pattern indicate that the reaction is an endothermic process. And from this data, we also can calculate the activation energy, the enthalpy, and another thermodynamic parameters. Yeah, this is the summary of the thermodynamic parameter. We got the enthalpy with this value, and we got the positive value for the entropy, and we got the energy energy free free energy gives energy free gives energy with this value 76.1 kilojoule per mole. For the last, we also studied the reaction mechanism. There are two commonly model to describe the catalytic reaction for heterogeneous catalyst. In this case, our catalyst is heterogeneous catalyst because it is solid in aqueous, aqueous PNP. And there are two. It is Langmuir-Hinshelwood and Ely radial, another one. To distinguish these two mechanisms, to confirm the pivot mechanism, we studied the effect of the concentration of the reactant, the two reactant, p-nitrophenol and sodium tetrahydroborate. And we got this pattern where the rate constant decrease as the p-nitrophenol increase, and the rate constant increase as the sodium tetraborohydrate increase. This pattern shows that the reaction follows the Langmuir-Hinshelwood. The Langmuir-Hinshelwood means that the two reactants firstly absorb into the surface of the gold nanoparticle, then the two reactants react forming a new product, p-amino phenol. So here our conclusion, nanoporosilica gold catalyst shows high efficiency in reducing toxic p-nitrophenol into valuable p-aminophenol, and the mass ratio of the two surfactant strongly affected the performance of the resulting catalyst, and we got the optimum catalyst is with this ratio, which achieves 95% conversion in only in 12 minutes with optimal pore size and surface area. And we got that the mechanism reaction follows this Langmuir-Hinshelwood reaction, and it has potential application in wastewater treatment and industrial catalysis. For the future work, we will study further the reliability, the stability, scalability, and testing on other nitro aromatic pollutant. And this is our outcome. We have published it in Key One journal with this impact factor, and this paper will be submitted soon with this title. Therefore, thank you for the Asahi Glas Foundation.
Thank you. Thank you very much for the very nice presentations. Also, congratulations for the publications. Yeah, it's very nice to have these publications. So I'm invite the questions from the audience. Is there any questions? Yes, please. Please, Ethan.
Thank you very much. My question is it easy to recover the gold from the nanostructure after the reaction? You mentioned the recycle would be your future work in the conclusion sheet. What do you think about that recovery?
For the recovery, we haven't done it yet, but we have some ideas. Usually, the recovery can be done by the acid-basic, acid-basic reaction. Maybe we will do it that way. But it is feasible, but we don't know the efficiency because we have done yet. We haven't done yet.
Thank you very much.
Okay, I have one questions for this works. So Did you also test it, the efficiency or the way the catalyst works by only using these gold nanoparticles metals or silver nanoporous? Yeah, I mean, so just these two without combining. Did you also test it?
Yes, actually, there are many report on that. We also tested it, but we only report that because it has been published in many papers. But yeah, using this support is much better compared to only using gold nanoparticles.
Can you share like how many improvement
Mm,
percentage or something?
this 92. Oh, I forgot, but it's. I'm sorry, I forget.
But
I'm sorry, I
this one
forget.
is much
Yeah,
better than
yeah,
this
yeah,
one.
yeah, yeah,
Okay, yeah,
yeah.
because I have
This.
also
Mm.
concern like, for example, is it possible using the other like cheaper metals like silver
Yes, yes, of
instead of
course.
this one?
Yes,
Ah, I see.
yes. Yeah, because the gold nanoparticle is more popular and more widely used
Yeah.
in this reaction, so we choose gold. But yeah, of course we can compare with other metals.
Okay. Yeah. Thanks very much. And we are hoping your next projects will be successful and give more impact for this one.
Yeah, thank you.
Okay. Please give a big applause for Dr. Ainul Makfira. And then we are going for the third presenter, Dr. Atar Lukman Ivansha. Please. Dr. Atar, is it already coming? Not, not yet, maybe. Okay. So we are moving ahead. One presenters and waiting later. Maybe Dr. Atar can join. So I'm inviting Dr. Azania Fibriani, SSE, MSE, and PhD from SCTH, yeah, School of Life Science. Please doing the presentations. Big round of applause.
Well, thank you very much. Thank you. So, good morning, everyone, ladies and gentlemen. Also, good morning for the representative of Asahi Glass Foundations. Thank you for coming and joining these presentations. So, I would like to present our research is about the cross-linked nano-immobilized mutant PETAs for degrading polyethylene terephthalate plastics. So, I would like to start it with. As you know, perhaps that plastic is the main problem for waste management. So every day we use plastic everywhere in Indonesia. As you can see, there's many abundance of plastic, especially in the oceans. So what approach can we do for solve these problems? So many things can we do to solve the plastic management problems for the chemicals or perhaps for physics, but we choose this way, we choose the sustainability method, we use enzymatic methods. So why we use these methods? Perhaps in 2016, one of the scholars is his, yeah, Yoshida Sensei from Japan. He discovered the PATase enzymes from the microbials that live in the ground. So, but from that day, the PATase is become one of the solutions to solve these plastic problems. But one of the weakness of this PATase enzyme, this has thermal labels and it doesn't have long-term enzyme activity. So if you imagine, if you want to solve these plastic problems, we need the enzyme that can stable in the thermal situations. And also you want to enzyme that can have long activity. So in 2019, we developed new enzyme we call mutant PATAs. So based on the PATAs wild type that discovered by Yoshida Sensei, we make new arrangements of the nucleotide of the gene of the enzyme, and we call it PATase mutant. And this PATase mutant is already studied in silico. It's already implemented in vitro by using the recombinant E. coli. And we see that this enzyme is stable and it has a higher activity than the wild type enzyme. So the big challenge, the another challenge itself is how to produce the enzyme in the large scale if we want to use this enzyme to address these problems, and how to use this enzyme continuously. So we don't want to produce the enzyme and then we just use one time and we don't use it anymore. We want to make the big, large enzyme productions, and then we want to use it several times before we cannot use it anymore. So the idea is we immobilize this enzyme using nanoparticles. So the nanoparticle that we propose is previously we proposed graphene. But then we see the sourcing in Indonesia is hard to find graphenes, oxidized graphene, I mean. So we changed a bit. We use the cobalt and copper. So for the use you making nanoflowers, and it will conjugate with the recombinant enzyme that we produce. So this is our method. So we produce mutant PATAs, and then we immobilize this mutant using cobalt and copper, and then we measure the activity of the enzyme, and then we see the degradation of PATA using the scanning electron microscope. And the result is like this. So this is we compare the activity of the free mutant PATAs. It means the enzyme but has no immobilization substrates. So the initial activity you see here, there is no difference significantly between the free PATase mutant and also the cobalt PATase mutant. But we see here, if we immobilize this enzyme using copper, it has different activity with the two other enzymes. But then we want to see how about the thermal stability of this enzyme. So we incubate the enzyme in room temperature in 40 degree, 50 degree, 60 degree, and 70 degree. As we can see here, the bar is show the free PTAs, cobalt immobilized PTAs, and copper immobilized PTAs. As you can see here, the optimal and the optimal temperature is 40 degree for the all three enzymes. But interestingly here, we can see here if we immobilize the PTAs using cobalt, we can see here that this enzyme has activity in the higher temperature, like 60 or 70 degree. While the free mutant PTAs, it has decreasing activity. So the storage also important because as in the fields, we cannot produce enzyme then immediately implemented the enzyme into degrading plastic. We need to think about how about the logistic chain to deliver the enzyme to the field. So we think that the storage stability is also important. So we try to examine how about the storage stability of the enzyme in the room temperature for 10 days. So as expected, the activity of the enzyme will decreasing along with the day of incubations. But interestingly, if we see here, it's also the same with free PTAs, cobalt PTAs, and copper PTAs. And we can see here the cobalt PTAs still maintain the lowest decreasing activity. So for the next is, we want to test how about the activity of the enzyme if we put this enzyme in the variable pH concentrations. So the idea is because we see the plastic and microplastics is contaminated the sea water or perhaps a river, not only the sea. So we want to apply this enzyme to the real field. So the real field, perhaps it doesn't have the ideal pH. So we tested the enzyme in the pH 4, 5, 6, 7, and 8. And we can see here, if we immobilize these PTAs into cobalt and copper, it doesn't have activity or lower activity in pH 4, 5, and 6. But if we do the activity in the pH 7 and 8, it has good activity. In fact, the cobalt immobilized, PTase cobalt immobilized with cobalt, it has the same activity with free PTase mutants. And as we check that the pH of the, for example, seawater is around 7 to 8. So it's quite ideal to solve these problems. And we check how about the reusability of the assay. So the free PTSA mutants cannot be reused because we just have first the enzyme and it's once a times use and we cannot use again anymore. But if we immobilize the enzyme with the nanoparticle, cobalt or coppers, we see that after 5 times, we can see the activity of the enzyme. So it means that if we in the field we want to like degrading plastic microplastic from the samples, we can try first trial for this enzyme here, and then we can use the same enzyme for the second time, 3 times, 4 times, and 4 times. So it's much more efficient than if the enzyme is not immobilized using nanoparticles. So we also see the characterization of the enzyme immobilized enzyme. So this is the copper PATase immobilized with copper, and this is PATase immobilized with cobalt, and we can see the nano flower structure here. If we make the resolution bigger, and this is the EDS analysis. So as you can hear here, for the cobalt, we can see there's cobalt like 20% of these samples, and the copper is like 30% of the samples. And then we try to degrade the PET films, and we examine using scanning electron microscope. So for this testing, we incubate the PET films using this enzyme at room temperature for 10 days. So it's real PET films, 10 days, and we check after the 10 days. So this is for free enzyme. You can see here, there's a hole here. So the hole that I show you, this is the regrading films of PET films, and it's also the same with cobalt and coppers. We also can see here that the active PET film is degraded if we use this to immobilize enzyme. So by seeing our results, we got confidence that we can apply this immobilized enzyme in the fields. So this enzyme itself is very easy to harvest because we engineer this PETase mutant in the E. coli recombinants, and it can be harvested by just take out the medium of the E. coli, so you don't have to lysis the cells. So for example, if you have big bioreactors, you cultivate the E. coli, and after several periods, you take the mediums and it contains the enzyme. And the immobilized method itself, we already optimize it. So it can be used, for example, if you have some samples, we can do immobilizations as very immediately. And we can see here that the nano immobilized is stable at least for 10 days. So the conclusion is that, so in this research, we see that the immobilization mutant PTAs using copper and cobalt successfully performs. And also we see here that the superior reusability of the enzyme compared the PETase, free PETase. And we can see here the nanostructure flower using the scanning electron microscopes. So that's all the result. Thank you very much for the Asahi Foundation that's already contribute with this research. Thank you.
Thank you very much for the very nice presentation. So we are inviting the questions from the audience. Is there any use the metals and then the enzyme? Yeah. So I just wondering, is it possible for modifying this enzyme? Yeah, for others enzymes that can be used, like for example, for the calorimetry. Yeah. So when there is the reductions or the oxidations that is occurs when the enzyme meets the PET, then there's some change of colors. Yeah, because just wondering, for example, for the easy detections and in the environment, whether we have some microplastics in the water or something. Yeah.
Okay, thank you very much for your question. It's very interesting if we can use this nanoparticle as a sensor also. So actually, if PET degrades, it can degrade into monomers. So the monomer of PET is terephthalic acid and also the ethylene glycols. And the one that can have colorimetry is ethylene glycols. So if ethylene glycols appears in the buffer, the color can be changed. So the answer, yes, it can be do by the colorimetry, especially if we targeted the monomer of terephthalic acid and ethylene glycols. But it is also interesting if we think that perhaps in the fields we don't have any spectrophotometry,
Yeah,
right?
that's correct. Yeah.
So we want to make sure that, for example, if you mix the plastic with the enzyme, you want to make sure that the enzyme already changed to the monomers itself. So it's very interesting to study again. I think because the cobalt and copper that we use, we don't characterize the spectrophotometry of these metals. But the enzymes is a protein actually. It has range of spectrophotometry, but I don't think that it can change the colors. So the one that changed the color, I think, is the substrates, not the enzyme. But I think it's a good idea to have like sensors, especially if we talk about the field that have
Yeah.
many tons of plastics.
Yeah.
Okay, thank you.
Okay, thank you very much. So please give a big round of applause for Dr. Azania. And we are going for the next presenters. Yeah, so previously Dr. Attar Lukman informed that there is his students that can do these presentations on behalf of him. So I invite Vera Faridatul Habibah. Yeah, please going for the stage.
Yeah. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Today I'm honored to be presenting research by Dr. Attar Ukman Ivansa entitled Unlocking the Potential of Biopolymer Doped Zinc Oxide Composite as Promising Material for Antibacterial Application. Okay, for the background of our research, it's from the increase of resistant bacteria caused by the misuse and overuse of antibiotic, which lead to a complication in treatment. For this reason, we develop a modified zinc oxide doped biopolymer to improve antibacterial activity. First, we synthesize the zinc oxides and zinc oxides doped by copper and magnesium using solid-state methods, and continue with coating by biopolymer, which we use inulin and chitosan for the coating. For the reason is because the inulin and chitosan is biodegradable, biocompatible, and low toxicity. So we can use they as antibacterial. After the coating process, we test the potential antibacterial agent to gram negative and gram positive bacteria to analyze the effect of the material. Okay. To analyze the successful synthesis, we use FTR analysis to the structural study of zinc oxide doped inulin composite and also zinc oxide doped inulin I'm sorry, chitosan composite, which the FTR analysis confirmed the successful synthesis and modification of zinc oxide nanoparticle through copper and magnesium doping, as well as their subsequent coating with inulin, which we can see here. The vibration fix from zinc with oxygen can be seen in area at 500, and also there's vibration fix from functional group from inulin. And next, we for chitosan, the same result is also observed, which the after spectra of chitosan can be observed in fingerprint area, which also show the functional group. I'm sorry, for the zinc oxide and copper oxide and also magnesium oxide from the FTR spectra. And we also do crystallinity study of inulin dope zinc oxide composite, which from this figure here we can see the zinc oxide copper, and zinc oxide magnesium have a sharp peak. And in comparison to after coating, the coating show more broader peak, which show that the successful of coating process to zinc oxide nanoparticle. And here is the antibacterial activity of zinc oxide doped biopolymer composite. To analyze the potential of antibacterial activity, we use spectrophotometry methods, which we analyze the optical density at 600 of the growth of bacteria, which we use for gram negative, we use E. coli, and for gram positive bacteria, gram positive bacteria, we use Bacillus subtilis. The result here show that we can see here control with addition of the material, and for after the addition of the zinc oxide, the growth of bacteria from Bacillus subtilis and Escherichia coli reduce the optical density, and there is increase in antibody activity after the addition of doping with copper and magnesium. However, after the coating with chitosan and inulin, there is reduce in antibody activity, except for after the coating of inulin with zinc oxide copper, which show higher antibacterial activity. With the conclusion is first, we successfully synthesized the zinc oxide doping with copper and magnesium. We also successfully do coating with inulin and chitosan. However, overall the finding highlight that both dopant selection and surface functionalization critically influence the antibacterial performance of ZNO-based nanocompounds, and this parameter can be strategically tailored to target specific bacterial type for optimized antibacterial application. Yes. Okay, thank you for the attention. This concludes my presentation, and I also want to thank you, Asahi Glass Foundation, to support this research.
Thank you very much for the nice presentation. So we are going to the questions. So is there any questions from the audience? Okay, so in that case, I have some questions. So in this case, what is exactly the of the inulin? Yeah, Miss, I see the tables previously. Yeah, so in this case, when I check the comparisons, I think the highest one input for Bacillus and Escherichia coli is zinc oxide magnesium, right? Yeah, from 65.97 and 89.36. Yeah, so Miss, is there a special you use this inulin for this research?
We use inulin as biopolymer, especially to increase stability and which could affect their antibacterial activity.
Oh, so for the stability, using the inulin is giving much better for this one.
Especially.
I see. And how about this, the potential? Yeah, potentials of this biopolymers. So will it be used for the biomedicals or something? Or do you have things in mind for the impact?
For future research, we interested to use inulin in nanofiber, which uh, incorporated with zinc oxide and or zinc oxide dope copper or magnesium. Use as nanofiber, which use in scaffolding.
Oh, okay. Yeah. Okay. Yeah. Thank you very much. Yeah. For presenting on behalf of Dr. Atar. Yeah. Okay. Please give a big applause for Dr. Vera. And then we are going for the next speaker by Mayrina Firdayati, SSC MT. Yeah. Please come to the stage.
Yeah. Good afternoon, Bapak Ibu, ladies and gentlemen. First of all, I would like to thank Asahi Glass Foundation to support our research and to give me and my team opportunity to conduct this preliminary study of bioconversion of sludge using black soldier fly larvae. So as per our initial proposal that we only plan to test this method with the sewage sludge, but then we decide to expand our scope to include various type of sludge that pose significant problems in environmental in Indonesia, especially or particularly in West Java. Sludge is a major issue, yeah, because even though it originates from a wastewater treatment plant and has potential to use as a fertilizer and also as a compost, its utilization in Indonesia is still very minimal because people are likely hesitant to use it, yeah, even give free. So in wastewater treatment plant is often simply spread out the sludge to the ground of the wastewater treatment plant. So once the facility can no longer accommodate the sludge, then the local authorities have to find a place, yeah, or a new dumping ground or temporary storage site for the sludge. Yeah. So it's happened also for Jakarta province because they have a lot of community wastewater treatment plant and they have also problem with the sludge. So meanwhile, not always in Indonesia is handled by proper wastewater treatment. So yeah, either to the lack of access or unavailability of wastewater treatment facility in the area. So the result is fecal, fecal sludge then being illegally dumping to the river. Yeah. Even, you know, we have desludging trucks in Indonesia, but they also dumping to the environmental or especially to the river. Yeah. So beside these two sludge, the human sludge, yeah, that's coming from human waste, we also use sludge that derive from slaughterhouse, yeah, from cow manure and also bovine blood. And the last one, we also use the sludge from a reservoir pond of the Dago hydroelectric power plant. Yeah, you know, the upstream area of Dago of Cikapundung River has seen an increased activity, yeah, with the housing and also agricultural activities like cattle farming. Yeah. So all of these activities is lack of proper of wastewater treatment facility. So their wastewater is discharged directly to the Cikapundung River. Yeah. So then we have in the middle we have a hydroelectric power plant. So they have to use the water from the river to turn the turbine, but the water quality of the river is already down. So then they take the river water and store in the reservoir pond, and then allow for sedimentation before the water is used for turn the turbine. Yeah. So we then use this sedimentation sludge because the plant practice of regularly discharging to the river Cikapundung make a problem and a big protest to community in downstream area of the hydroelectric power plant. Yeah. So all the sludge that I saw and mentioned to you is same have a same common characteristic. Yeah, they still have a high concentration of organic matter content, and also so that makes them potential for as a food for black soldier fly larvae. On the other hand, our research also indicates that the these sludge also contain high content of pathogens like indicator is E. coli, and also have high heavy metals, yeah, that's posing a risk not only for the human but also for the environmental. So there we decided to use black soldier fly. Actually, using this larva is new for us in environmental engineering because, yeah, usually our colleague from biology that have research with this, yeah. So, yeah, you know, black soldier fly larva is very popular now for conversion of solid waste, yeah, domestic solid waste in Bandung and in ITB also, yeah. But so that's why we use this. We try to use this to get to see the potential to reduce the problems with the sludge, yeah. So for our experiments, we created several substrate variations, we didn't just use the sludge itself, but we also make a combination with other varied substrate sources that are common ways in the areas where the sludge is found. For example, the fecal sludge, the fecal the fecal sludge, yeah, we collected from a communal septic tank in Bekasi on Java's northern part, northern coast. And we made combination with fish guts, leftover crab, and also mangrove fruit skin. And the sludge from wastewater treatment plant and the sedimentation sludge in Dago hydroelectric plant, we combine with the cabbage waste from a nearby traditional market, and the animal waste from the slaughterhouse was combined with bovine blood and also coffee pulp uh, that we that grow around this slaughterhouse. Yeah, we also fermented the animal waste substrate to see if fermentation would improve the feeding efficiency of the black soldier fly. So for this research, we also use 6-day-old of black soldier fly and feed them once every 3 days. And we measure the larva weight, waste reduction index, the efficiency of conversion of digested food, survival rate, and also the heavy metal content. So for the result that we get that so the black soldier fly is larvae are capable of converting the nutrient content of the sludge. As you can see here that the survival rate is more than 70%, and also we get the highest survival rate is reaching 95 to 96%. But their growth was slower than we expected, as some larvae also have a delay reaching the prepupa stage, yeah, because their nutritional needs were not fully met. It's disrupted their life cycle, yeah. So additionally, their weight gain and length increase, but not as ideal as when using typical domestic solid waste that we get from the market. So, but in other side that when we combine the sludge with the other substrate sources, is proved to be effective in improving growth. Yeah, the waste reduction index, which describes the larva ability to reduce feeding substrate, so promising results. Yeah. For instance, the combination of sedimentation sludge and cabbage achieve waste reduction index of 5.74%. Is almost the same like when we use this black soldier fly to convert cassava pulp and also bread. Yeah, is also have a similar range. Yeah. Meanwhile, the combination of fecal sludge and fish viscera or fish inert achieve waste reduction index of 5.2%, yeah, and the highest feed conversion efficiency, yeah, in 6.6%, yeah. But actually, it's kind of lower if we compare with the other values study, yeah. For example, if we use like pandanus fruit, the ACD can reach until 27%. Yeah. But if we compare again with other substrate that have high carbohydrates, or like rice straw, yeah, with larva. The typical range is from 5 to 10%, yeah. So it's almost in the similar range. So if we see the characteristic of sludge, yeah, it has a high polysaccharide content, so, and relatively low nitrogen and also phosphor. It become key factors, yeah, why the acid is not really good, yeah. So so it's also, if you can see, it's from the weight gain that we get. The best result were obtained from the when sludge was combined with other source of substrate, yeah, like organic or food waste. Yeah. So this allow the larva reach an ideal weight for animal feed. Yeah, but we still have a problem with the using the blood here. Yeah, because actually blood is really rich with the protein and phosphor, but we still have a problem even we try to heating, or in this case we also try to ferment. We still have like ammoniac gas produced, yeah, in this process. So the palatability of larva is they say, oh, it's not a good food, yeah. So they want to eat this combination. So we still have a problem, and try to explore another methods to pre-treatment the blood, yeah, in the future. So, and regarding heavy metal bioaccumulation, we found a very result, actually, yeah. So the process of accumulation seems to depend on the type of the metal, the substrate, the metals concentrations, and also the initial condition of the larva itself, yeah. Some experiments show that the metal accumulation in larva bodies, like in blood waste, in sediment sludge, we found cadmium and also chromium. Yeah, but in other case, like the sample from fecal sludge that from our characteristic, initial characteristic have heavy metal, but in the body of the larva, they don't accumulate this heavy metal. Yeah. So, so based on this research, we concluded that there is indeed bioaccumulation of metals in larva bodies, but we also get insight that these heavy metals can be released to the residue, and FUV. FUV is the outer skin of the larva. So when they want to become bigger, they open their skin, yeah, and it's mixed with the residue. And for the sludge, we still have a problem to separate between the residue and the FUV and the outer skin. So maybe it's also our homework for the next research. So then we can get a balance of heavy metals in the black soldier fly. So okay. Yes. Okay. So this can so using the black soldier fly larva, we have the opportunities and also but the challenge. So we think we need to do some research in the future because you know for black soldier fly it's really popular now and easy to use it in many places. Yeah. So yeah, in the future we will do some research, especially about the heavy metal content, because we don't want our cattle eat a food with the heavy metal content, heavy metal content inside, and also the pathogen inside. So I think that's all. Once again, thank you for the opportunity to do this research with from Asahi Glass Foundation. Thank you.
Thank you very much for the nice presentations. So I invite the questions from the audience. Okay, please.
Thank you very much for the very interesting presentation. So I was wondering, so BSF is largely used for example, for protein source for fish food. But what I understand is that there's no metal accumulation in larvae, right? In the larvae, there's no metal accumulation in this case.
Yes, that's what we read from the literature also. But in our case, we try to check the heavy metal content in the larva body, and we found is exceed the safe concentration if we want to use as food for animal.
So in this case, the larva is safe for for fish exactly. In this,
Not really.
okay.
So that's still a question to us, but so maybe it's the for the future experiment we try to get why some larva can accumulate to the outer skin, but some larva accumulate in the body. So
Thank you very much.
Thank you very much. So please give a big applause for Dr. Marinia. And we are going next for the next presenter, Dr. Eng Insinyur Firman Bagja Juangsa, STM Eng. Please come to the stage.
Cek cek. Ya, Bismillahirrahmanirrahim. Oyo gozaimasu. Kikai koku gakubu no firman tomoshimasu. Since you talk in Japanese, so in Indonesian, I talk in Japanese. But no, yeah, I will continue in English. So good morning, everyone. My name is Firman Bagja Juangsa from Mechanical and Aerospace Engineering, and on behalf of the research team, actually consists of several faculty members and also our recently graduated doctoral student, Rico, Dr. Rico, which is currently a faculty member in of Institute Technology Sumatra. So he came from Sumatra to here, and I would like to present our research regarding the investigation droplet and spray injector behavior enhanced by iron-based nanomaterial in pure palm oil for diesel engine. So this is the outline of my presentation, and let's just get into the introduction without any further explanation. Indonesia is currently in energy transition to 2060 net zero emission. And as you can see here, all the renewable energy, including the biomass and biofuel in Indonesia, is on increasing scale. But on the other hand, if you can see here, the renewable energy realization in Indonesia is a bit lower than its target. It should be in 2025 is around 33%, and currently not even 15%. So this is actually the challenging for us. But another good news is you can see here that based on the progress, you can see that in transportation, direct renewable energy accumulation is almost exceed the target. Currently is almost 13.5%. So this is actually good news because the program of biodiesel in Indonesia is, I think, leading sector compared to other countries in the world. So I think we have to continue to support the renewable energy utilization in transport sector. And talking about the palm oil and biodiesel, I think we know that Indonesia is the world's largest palm oil producer with more than 40 million ton per year, and part of that is currently used in Pertamina to produce B40 and B65 for biodiesel.
So I think these are quite good potential in Indonesia for biomass and biofuel. And talking about the biofuel, biodiesel is actually the target. But then producing biodiesel has a lot of challenges because it needs catalysts and also processes and cost effectiveness. So we would like to do the study of using the pure palm oil PPO in diesel engine. But as you may assume and guess that there are a lot of technical problems. Yes, as you can see here, there are five main problems for crude palm oil. But by converting a simple process of producing the pure palm oil, then we remain have three problem of viscosity, carbon deposit, and low volatility that we would like to analyze further in this research. So yeah, just to give you a context of how we can develop the engine or the fuel, but this is actually the two-way of development of alternative fuels. We can modify the prime mover of the engine so it can modify and adjust with the what fuels it will using, but also we need to also to how to adjust the characteristic of alternative fuel to be able to be consumed in the diesel engine that we are currently using. So the goal is achieving how to compatibility while maintaining efficiency and compliance with standard. And in this research, we currently still on the laboratory scale experiment. And of course, in long term, we would like to continue to field testing and market adoption for a longer roadmap of this research. So talking about the nanoparticles in this research, there are so many research on how to utilize nanoparticle in enhancing the combustion in the engine. We know that it can increase the engine performance as well as also enhancing the spray visualization or the fuel atomization in the engine. So we further would like to evaluate several kind of nanoparticles that we use in order to enhance the combustion characteristic as well as the spray characteristic in a diesel fuel. So let me begin with the seven. We did a study on seven candidates of nanoparticles. Basically, we can classify into two big groups. The first one is carbon base and metal base. So we just listed all the characteristics such as low cost as well as the mechanical and thermal properties of each nanoparticles, but I would like to emphasize more about the morphology. At the end of this research, we know that this morphology is quite important to create the micro explosion as well as enhance the spray characteristic inside the engine. And of course, as you may expect, we did the SAM characteristic to know to find out the average size of each nanoparticles. Basically, in nanometers, scale from maybe around 20 nanometers to hundreds nanometers. But again, I would like to show you that goethite has a needle nanorods, which is quite greatly contribute to the characteristic of combustion as well as the spray. So this is the geotite. What is it, geotite? Yeah, this one. Yeah, is nanorods or like needle-like. Yeah. And we continue with the fuel analysis. Basically, this is the basic or the common analysis that we do in each fuel. Basically, we would like to know the heating value, density, viscosity, surface tension, and flash point. Surface tension is important for spray formation and atomizing. And how we blend the nanoparticle, we just use the simple process of sonication to get the homogeneous and stable blend of the fuel. And then we get it into the engine to be tested. And these are the results. As you may see that basically the pure palm oil has much higher, and this is quite challenging for engine, but thanks to several maybe the fuel additive, it can reduce in, for example, in carbon nanotube. But for density, it basically doesn't change significantly. But you may see also because the base fuel is different, it has lower heating value for all of the pure palm oil compared to the diesel fuel. And for the surface tension, you may know that this pure palm oil and in the additive didn't help much on how to improve the or reduce the surface tension, so we can have a broader spray on the in the engine. Yeah. But for flashpoint, basically all the palm oil has a higher flashpoint. This may disadvantages for the combustion, but for handling, it may give you maybe a safer handling during the fuel transportation. And let's get into the main one is engine testing. So we did this engine testing with the single piston engine, the basic one, and we use several measurement fuel heater to get the stable temperature, and then we measure the smoke opacity meter and also the load. So we varies the load of the engine, and we know the characteristic of the engine. So these are the engine performance. As you may see here, there are quite a lot of result here. We interested to discuss one by one, but as you may see here, basically the carbon nanotube has quite increased by 8% compared to diesel fuel, but the highest is by the silica or silicon dioxide, highest gain of 16% at 60% load and compared to the diesel fuel, while the other may have decrease and lower power outcome of the engine. Also, we measure the specific fuel consumption. This is important because we want to be high efficiency, so we need lower specific fuel consumption. In SFG, we can see that the acetylene black, the SFG decreased at 60% load with the decrease around 13.73%. And other, like for example, graphite oxide, for example, here has a lower decrease, yeah, only minus 5.6% at 80%. But there are some, we will have to be end of this presentation to know what is actually the best additive for this engine. And the last one is thermal efficiency. We compared with the diesel fuel and pure palm oil. And in graphite oxide, we see that the thermal efficiency increase with the maximum is around 20%, above 20%. Also happen in the acetylene black additive, while the zinc oxide, for example, doesn't give you the good thermal efficiency changing in all the engine load. As for the emission, we only measured the smoke opacity. Quite varies the result. But if you want to use the, for example, silicon dioxide, for example, it exceed the government regulation, while the best one maybe is graphite oxide or the goethite one, which may give you lower or maybe cleaner smoke opacity compared to the diesel fuel engine. Yeah. So it has some potential reducing the smoke opacity in this additive. Yeah. And we further did the carbon deposition measurement, not only measuring the smoke, but also we did open and see the condition of the engine, yeah, after 35 and long-term testing of the engine. And we did, this is the basic one in mechanical engineering. We divide into 12 a region of the piston and cylinder head, and later on we see how dark, how dirty is the engine. And this is the result. This is doesn't give you any quite clear because the picture doesn't give you clear one, but we later on quantitatively see the amount of carbon deposition. You may see here that maybe PPAO, of course, so average carbon deposit is around here. The J1 is the peak one. But compared to the pure palm oil, we can see that the goethite has good best performer. It can reduce the carbon deposition by minus 75% to the PPAO. Very clean compared to other additive. Yeah, it may range the several numbers, but actually we have the goethite as the best candidate for the additive. Yeah. And the previous one is on the piston. This is the cylinder head. yeah, similar result actually. The result shows the carbon nanotube and geotite. I think the best one for the additive to reduce the carbon deposition on the engine. And for the spray characterization, we did in our laboratory with simple high-speed camera setup, and we measured the spray condition to know whether the spray is can mimic the diesel fuel characteristic or not. And these are the results. You can see that the ideal diesel fuel have the very broad and diffusive spray like, but the palm oil very neat, very small, and yeah, narrow spray. And by introducing several kind of additive, for example, yeah, carbon nanotube, for example, it may not have the same one, but at least better than the pure palm oil, for example, including the maybe around the beginning of the experiment. Yeah. So not really clear, but yeah, we can see some improvement if we are using this different kind of additive in the fuels. So I guess this is the conclusion. The conclusion is we know that there are a lot of candidates of this additive, but in the performance, actually the addition of additive improve the performance with the average of maybe around 2.2%. And for the smoke emission, as you may see previously, that the graphite oxide reduction of -18, goethite is -64, and the RGO is -54. But I think the one of the most important one is carbon deposit, because it may affect your life of the engine. The reduction shows best for carbon nanotube and goethite, followed by other additive. As for the spray behavior, I think we need to improve further how to improve the spray characterization of these additives. For further, of course, we will continue this research by engine durability tests, of course, and also numerical simulation. And we need also to do this techno-economic, because we need to assess whether this economically is viable or not for utilizing these nanoparticles. And for the outcome, we did publish last year, end of the last year, for this research publication. I think that's all presentation from me. Thank you.
Thank you very much for the presentation. So we are opening the questions from the audience first. Is there any questions? Yeah. Okay. So I have some short questions. So in this case, you use this, yeah, several kind of additive. Yeah. And do you think, I mean, in the case for the gas exhaustion, I mean, is there any, which one is best, which means that the emissions and the chemicals is less harmful from one?
Yeah, thank you, Ansori. Actually, that is the full scale emission assessment will be carried out after this, because in diesel, usually smoke opacity is the most common and easy way to see whether the dark smoke from the engine is emitted or not. So based on this smoke opacity, I think two of the candidate, which is graphite GO and GOE, is one of two. I think two of 7 of the candidates that may be better than diesel fuel. However, we need to confirm other emission as well. So, for example, NOx, for example, and also CO, for example.
Yeah,
I think that will be carried out in the next one. We are preparing the experimental setup.
Okay, just and then one small questions. So in this case, from this all kind of additives, all of them maybe not reacted this surface of the engine. Did you have some opinion with that for the long terms using of this machine?
Yeah, very interesting question. Actually, we haven't carried out that, because the longest testing that we carried out is only 17 hours. Usually, for example, different lubricants or different fuel for engine, we need to at least using at least a month or 2 months based on the standard, so we know how is the long-term operation of the engine will affect the engine life. Yeah, I think that also will be carried out later on. Thank you.
Okay. Yeah. Thank you very much for the nice presentation. So please give a big round of applause. And then we are coming for the last presenter by Dr. Maria Apriliani Gani. Please take the stage.
Okay, good morning, everyone. Thank you for joining me here today. In this presentation, I'd like to share about our recent work on the development of biomimetic hydroxyapatite bone graft by using 3D printing technology for bone defects therapy. Okay, let's start with the basic. Bone grafting is a surgery to repair or replace damaged bone. It's often needed after a serious accident or when part of bone has to be removed, for example, because of a tumor. At the moment, the gold standard is still the autologous bone grafting, means using bone from patient's own body. It works well, but the problem is it comes with a lot of limitation. For example, limited donor bone, extra surgery, and sometimes painful complication. So the question is, what's the alternative? One promising option is a material called hydroxyapatite or HA. Why HA? Because our bones are mostly made of it. HA can be extracted from natural source or can be synthesized in the lab. And as a biomaterial, HA perform good properties like biodegradable, biocompatible, and also support bone growth. But here's the catch. The pure HA, meaning only contain the calcium and phosphorus, is not osteoinductive, meaning that it cannot actively tell precursor cell to become new bone cells. And interestingly, the HA in our bone is not just pure HA. It actually contains trace element. And researchers found that the magnesium and sodium are the key ones. This discovery sparked the idea, if we added magnesium and sodium into synthetic HA, maybe we can give it osteoinductive properties that pure HA lacks. This idea is also supported by our previous study. We previously developed nanosized HA from natural source and found that it had strong osteoinductive properties, precisely because of the magnesium and sodium. And building on that, in this research, we developed magnesium and sodium doped HA as a bone graft to treat critical size bone defect. And by using 3D printing, we were also able to make graft with precise control of size, shape, and volume, which opening door to patient-specific customizable bone graft. And our bigger vision is simple. We want to reduce the dependency on import medical device and support the production of domestic bone graft. Okay, let me show you how we synthesize this material. We use wet precipitation method to synthesize the material from chemical precursors, and to confirm the success of our synthesis, we perform several characterization. The first one is based on XRD result. We can see here that the doped HA, the pure HA first, exhibited a typical pattern of hydroxyapatite with no secondary phases detected, while the doped HA, the HA doped with magnesium and sodium, exhibited slight changes in lattice parameter as well as the cell volume that indicating modification on its crystal structure compared to the pure ones. And based on the TEM result, we can see here that both materials were sized in nano, while based on the XRF analysis, we can confirm the elemental composition. With calcium and phosphorus were dominant, and on the dope HA, we also can detect magnesium and phosphorus just as expected. Okay, So after confirming the synthesis, the next question was, are these biomaterials safe in biological environment? Since bone graft always in contact with blood, the first thing that we need to make sure is their hemocompatibility. And based on our result here, figure 3A, both materials showed very less blood lysis. And at the highest concentration, the doped material showed lower blood lysis percentage compared to the pure ones, indicating better blood compatibility. And we also confirmed the cytotoxicity of this material with pre-osteoblast cell line on figure 3B, and it showed good result. And after that, we also look at the osteoinductive potential of this material by using two staining. The first one is the alkaline phosphatase staining, figure 4A, and the second one is the alizarin red staining. So alkaline phosphatase is a marker of osteoblast differentiation, meaning that osteoblasts already differentiated into the mature bone. And the alizarin red shows the mineralization nodules, meaning that a positive result will tell us that the pre-osteoblasts already differentiated into the mature osteoblasts and gain their function on bone synthesizing cells. And we can see here from figure 4 that cells treated with dope HA showed intense staining, more intense staining compared to the other groups. And overall, these results show us that the dope HA is not just safe and also biocompatible, but also shows better osteoinductive capacity. Okay, before moving into the 3D graph fabrication, we previously conduct a preliminary study by using meta-analysis to identify which material characteristics that perform best from the clinical trial. And we found that a material called polycaprolactone, or PCLs, performs very well. That's why we also use this material as our graph template. In making the graft itself, we didn't just focus on making the graft, but we also optimized the mechanical strength of the graft. That's why we print the graft with 5 different pattern design on the figure 5 and check the mechanical strength performance. And what we found here is that a pattern called honeycomb performed the best, and we use that pattern to our 3D graph fabrication. And beside that, we also treat the PCL with alkali treatment to create a Rauger surface area, addressing the limitation of the PCL itself. And after that, we incorporated the ceramics that previously synthesized as a 3D graph material. Okay, after the graft were fabricated, we also want to check whether cell could attach to them or not. And based on our finding, the cells can attach to all graft. And encouraged by this in vitro result, we then move our study to the in vivo study. And this year, we got additional research funding to continue our study as a follow-up to the Asahi research grant. And in this study, we conduct an in vivo study to the experimental animal. The study is still ongoing actually, but we already obtained some data. One of them is the microcity image of the treated animal. And if we look at the grayscale image of the microcity of figure A, we can see here that when animals treated with the bone graft, it showed something like bridge bone. But when we examine deeply by using the density of the picture on figure B, we can see here that some groups appear not bridge, meaning that it had lower density area, indicating incomplete mineralization or residual graft. While on the doped HA group, it showed high density area, indicating better bone formation. And overall, our results showed that when we use dope HA as a bone graft, it can induce more bone growth. Okay, so what all these findings tell us in a bigger picture? Our research showed that when we doped hydroxyapatite together with magnesium and sodium, it can enhance the osteogenic activity, biocompatibility, and also other good properties. However, how precisely this material interact with bone cell, we still don't know. Whether it's attached to cell receptor or taken up via endocytosis, for example, or what kind of cell signaling that they activate, we still don't know and want to explore in our future study. And from this current study, we also had two outcomes. One is published a meta-analysis in top 10% journal, and we also still have one under review original article. Before closing, I'd like to acknowledge the people and institution who made this research possible. This research is a team effort with myself and Prof. Iketut Atiana and some great students here. And also, we want to acknowledge the college who helped our study, as well as the Asahi Glas Foundation for the overseas research grant. And with that, I close my presentation. Thank you very much for your attention.
Thank you very much for the very nice presentations. So we are going for the questions sessions. So is there any questions from the audience? Okay, in that case, I have questions. So, but although I'm not seeing here, so in the case of this, when we are try to implement the 3D printing, so we will use the, what is that? The filament base or resin liquid base? Yeah, I mean that can be implemented with your research. So which one that we can be used?
Okay, thank you for the question. Yes, in this case, we use filament PCL because we print the PCL first and incorporate it into the synthetic hydroxyapatite. Why? Because we aim to maintain the mechanical strength. Because when we mix the filament, for example, or powder thermoplastic material with the ceramics, it will lowering the mechanical performance of the graft. That's why we only print the material first and incorporate it with our ceramics that we synthesize. Thank
I
you.
see. So it means like the printed of these 3D structures, and your material is like a coating outside of this one, or it will also penetrate this PCL layer.
Okay, only coating because the aim actually is only to attract the bone cells. And when the bone's already there, they can grow and proliferate and differentiate to become a mature bone. So while supporting the bone itself, for example, when we use it in low extremities area, we can induce the bone growth on the scaffold, not just like the metal implant, if you know. Metal implant, we have to remove the graft. But in this study, we hope that it will be degraded naturally.
So you hope and your team hope that the PCL itself is also degraded in the body.
Yes, because it's biodegradable as well.
Okay, yeah, that's very nice. Yeah, Miss, I asked a little bit many questions because I'm from medicals.
Okay,
So
thank you.
yeah, little tested with this one. Okay, yeah. So maybe we can close up the first sessions in the morning. We are thanks very much, and I go back for the MC for this information for the next sessions. Thank you very much on behalf of me, and I also thanks from the Asahi Class Foundation. Thank you very much.
Okay, thank you so much, Dr. Ansori. Well, ladies and gentlemen, it has been a fruitful series of presentations, right? Now that I see lunch is provided, may we warmly invite you to indulge you with Indonesian flavors. Please bear in mind you cannot bring your food here because also we have provided some round table in the gallery, and while you're eating, you can also look around on the poster sessions that we held in the gallery. So let's go. What are we waiting for? Itadakimasu. Back, ladies and gentlemen, we are going to start the event soon. Please be seated because we are going to start the grand ceremony anytime soon. We still have a lot of chairs over here. You can also choose the chairs over here if you like. Good afternoon, ladies and gentlemen. Welcome back to the grand ceremony and seminar on research findings supported by the Asahi Glass Foundation 2025. We will now listen to the Senior Executive Director of the Asahi Glass Foundation, who will kindly deliver a message from Mr. Takuya Shimamura as the Chairman of the Asahi Glass Foundation. Please welcome Dr. Naoki Sugimoto.
Good afternoon. Our chairman, Mr. Shimamura, is chairman of both our foundation and also AGC Incorporated company. And due to the company rule, now actually he's in Jakarta, but he cannot move to Bandung because of the company's rule. So he's so sorry not to come here. So today I will read his letter to all of you. Let's start. Thank you very much for your kind introduction. Yang saya hormati, bapak-bapak dan ibu-ibu sekalian. Selamat siang dan salam sejahtera. Nama saya Shimamura, Chairman dari Asahi Glass Foundation dan Chairman dari AGC Incorporated. It is from here English. It is both an honor and pleasure for me to share my message today as a representative of the Asahi Glass Foundation in Japan. Firstly, please allow me to extend my sincere gratitude to Professor Tatachipta Dirgantara, the rector of ITB, Professor Abilizuki Zuharu, Vice Rector for Research and Innovation, and Professor El Fahmi, Director of Research and Innovation, and our distinguished guests and the members hosting today's ceremony. Terima kasih banyak. Secondly, let me introduce Asahi Glass Foundation briefly. The Asahi Glass Foundation was established in 1933 to commemorate the 25th anniversary of the founding of Asahi Glass Company Limited. The company itself was founded in 1907. Since then, the company has been expanding its business from glass to chemicals, ceramics, electronics, and life sciences. And Asahi Glass Company was renamed AGC Inc. in 2018. Today, AGC is operating business in more than 30 countries. The total number of employees is approximately 60,000 people, and annual sales revenue is approximately 20 billion US dollars. In terms of relationship between AGC Inc. and Indonesia, in 1972, AGC began to produce flat glass in Indonesia and expanding its business to automotive glass and chemicals. Today, total annual sales revenue of group in Indonesia is approximately 1.4 billion US dollars. We are also pleased that many graduates from ITB joined Asahi Mass Flat Glass and Asahi Mass Chemical. Thank you so much. Let me go back to the introduction of the foundation. Now our foundation provides 4 major programs, which are research grant program and scholarship program commendation program named Blue Planet Prize, and environment learning support program for young generations like high school students. In 1988, Asahi Glass Foundation launched our grant program with ITB. So this year is the 37th anniversary. I would say AGC Inc. and Asahi Glass Foundation have a long history with Indonesia and ITB as well. We have supported 366 grant subjects so far, and we will support 14 grant subjects this year. Congratulations for recipients. I believe these research results contribute enough for the development and prosperity of not only Indonesia, but also all over the world. We hope our support will be helpful for your researchers. And as one of the major activities of our foundation, we have been awarding Blue Planet Prize since 1992. It has grown to become an internationally recognized award. Each year, the Blue Planet Prize is presented to 2 individuals or organizations who have made outstanding contributions toward solving global environment issues. The award includes a certificate of merit, commemorative trophy, and a prize of 500,000 US dollars per recipient. From Indonesia, Dr. Emil Salim, the former Minister of Population and Environment of Indonesia, was the laureate in 2006 Blue Planet Prize. And this year's Blue Planet Prize laureates were announced in June. One of the laureates is Professor Robert Jackson in Stanford University in the US. And the other laureate is Dr. Jeremy Leggett. He is founder and CEO of Highlands Rewilding Limited in UK. And also he was the first chairman of the Carbon Tracker Initiative. Please visit our website, which explains the achievement in detail. The presentation ceremony will be held in October in the presence of their Imperial Highness Crown Prince and Princess Akishino. They have been supporting the Blue Planet Prize more than 30 years. As you know, our environmental situation is getting worse every year. Humanity has achieved prosperity at the cost of the environment. That is the reason why we established the Blue Planet Prize. I hope the laureates of this prize from Indonesia will be awarded someday again. I sincerely hope all the researchers here will contribute to our precious Blue Planet through your research. Once again, I'd like to express my deepest appreciation to Professor Tatachipta Dirgantara, Professor Ravi Rizuki Zuharu, Professor El Fahmi, and all members concerned kindly supported the grant ceremony and seminar as well. As closing my speech, I'd like to leave with this message. I firmly believe in all of you. Your future is bright, your potential is unlimited, and your possibilities are endless. Terima kasih banyak. Thank you. Takuya Shimamura.
Terima kasih banyak, Dr. Sugimoto. It was very perfect. Would you please remain over there? Oh, okay. So this is the moment that we are all waiting for. We're going to call the recipients one by one to receive the certificate from Dr. Sugimoto. Can we please kill the projector light? Because it's really... So at this moment, we kindly invite the award recipients to come forward and receive the certificates from Dr. Naoki Sugimoto. Brian Bramanto, STMT, PhD, from the Faculty of Earth Sciences and Technology. Can we move a little to the center for pictures? Okay. Look at the pictures, smile. All right, thank you. Dr. Bramanto, you can wait over there for a little bit, okay? Dr. Rernat Suliskania Nurfitri from the Faculty of Earth Sciences and Technology. For pictures, okay. Thank you. Dr. Nurfitri, you can wait a little bit. Robi Roswanda, SSI, MSI, PhD from the Faculty of Mathematics and Natural Sciences. Thank you, Dr. Roswanda. Antonius Indarto, STM Eng, PhD from the Faculty of Industrial Technology. Okay, thank you, Dr. Indarto. The next one, Professor Dr. Satria Bijaksana from the Faculty of Mining and Petroleum Engineering. I think this is a returnee, yeah, awardee. This is not his first time receiving this grant. Thank you so much, Professor Bijaksana. The next one is Professor Dr. Delik Hudalah from the School of Architecture, Planning and Policy Development. Thank you so much, Professor Hudalah. Dr. Fikri Zulfahmi from the School of Architecture, Planning and Policy Development, who will be represented by Nabila Dina Adarina ST MPWK. Thank you. Santi Novani SSI MT PhD from the School of Business and Management. Thank you, Dr. Novani. Dr. Liane Okdinawati from the School of Business and Management. I think everyone is so full with food, yeah, that the clapping is less and less. Professor Apotheker Diki Mudakir from the School of Pharmacy, who will be represented by Professor Dr. Apotheker Neng Fisheri Kurniati, SSI MSI. Thank you, Professor Kurniati. Professor Dr. Rernat Apotheker Sofi Damayanti from the School of Pharmacy. Thank you, Professor Damayanti. Dr. Rernat Apotheker Rahmat Mauludin from the School of Pharmacy. Thank you, Dr. Mauludin. Nur Ahmadi STM Eng PhD from the School of Electrical Engineering and Informatics. and Dr. Eng Eka Oktarianto Nugroho from the Faculty of Civil and Environmental Engineering. All right, thank you so much. We are going to have a photograph, okay? We would like to invite Professor El Fahmi to join Dr. Sugimoto to have the group photograph. Yes, with Mr. Usui. Okay, we can squeeze a little bit, yeah? Squeeze a little bit, like the lemonade. Okay, a little bit more. Okay. So, okay, so look at the camera over there. Ibu, boleh dilihatin itunya. Okay, all right. So 1, 2, 3. Everybody is, like, okay, can you come? Like, relax. Look at the camera. 1, 2, 3. Oh, with some poses, yeah. 1, 2, 3. Oh yeah, show your certificates probably. Okay, good idea. 1, 2, 3. Gambarimashou ka? All right, thank you so very much, ladies and gentlemen. Would you please return to your seat? So on screen, we can see all the recipients from this year's grant awards from the Asahi Glas Foundation. 14 researchers that we are looking forward to listening to their yes, presentation next year. It feels like in a blink of an eyes, right? For the grantees from last year. Now we see each other again, then you are presenting your presentation. So 1 year is just, very, very soon, yeah? And of course, we will see each other again. So, ladies and gentlemen, as we continue, it is now our pleasure to commence the afternoon session on smart and sustainable systems for cities, energy, and environment, which will be presented by the following research grantees. So the first one, we have Augie Widyotriatmo, STMT PhD from the Faculty of Industrial Technology. Professor Dr. Hendra Grandis from the Faculty of Mining and Petroleum Engineering, Dr. I Gusti Ayu Andani, STMT from the School of Architecture, Planning and Policy Development, Professor Dr. Sri Mariati, STMIP from the School of Architecture, Planning and Policy Development, Dr. Rerpo Eko Agus Prasetyo, STMBA from the School of Business and Management, Dr. Eng Pri Hermawan STMT from the School of Business Management, who will be presented by Raffi Ardianto STMSM. And last but not least, Zikri Firman Syahakam STPGDIP MSc PhD from the School of Business and Management, who will be represented by Anissa Nur. So, this afternoon session will be moderated gracefully by Dr. Windy Iriana STMT PhD from the Faculty of Civil and Environmental Engineering ITB. We are delighted to have you, Dr. Iriana. The floor is yours.
Okay, thank Tes. Okay, thank you very much, Miss Ossie, for the introductions. Good afternoon, everyone. So yeah, I'm Windy Riana, will be your moderator today. Um, okay, so maybe I will give a little reminder for the presenters that you will have 10 minutes for presentations, and we will have 5 minutes for question and answer. Okay, without further ado, I would like to invite the first speaker today, Dr. Augie, with the titles Localization Systems Under Canopy at a Remote Area for Agricultural Robots.
Okay. Good afternoon, ladies and gentlemen. Thank you for this opportunity. My name is Augie Video Triatmo. Today, I'll share my work on developing on localization system for agricultural robots operating under canopy in remote areas, supported by Asahi Glas Foundation Overseas Research Grant. So the agricultural industry urgently needs sustainable solutions, especially to address labor challenges. Mechanization is no longer optional, it is a necessity. For robots to operate safely and effectively, they must know where they are in their environment. So a reliable localization system provide this capability, enabling the robots to navigate, perform tasks with precision, and interact seamlessly with their surroundings. So in agricultural environments with the dense canopy, GNSS or global navigation satellite system signals often drop out or become distorted due to a multipath phenomena. However, for tasks such as spraying, harvesting, and crop monitoring, robots need centimeters level pose for localization. So the goal of this research is to develop a robust localization through a sensor fusion and also um, image-based navigation and tracking control. So to address this problem, we came out with our novel sensor fusion method called nonlinear observer unscented Kalman filter. So the method combined the determination accuracy of nonlinear observer and the stochastic method which deals with uncertainties. So we combine data from an inertial measurement unit, wheels encoders, and also differential GNSS. And here the unscented Kalman filter helps to handle the nonlinearities in the robot's dynamics, while the nonlinear observer improve the estimation accuracy when the input signals are noisy. Together, the nonlinear observer and also the unscented Kalman filters um, allow the robot to maintain a stable and precise localization even when the GNSS is unreliable. So here is the simulation results of the method of the nonlinear observer unscented Kalman filter, and we try to compare with the other method like extended Kalman filter and also the unscented Kalman filter itself and CKF and HUKF, and we found out that our method yeah, it is showing the prominent result where it is close to the ground truth of the measurement. In the experimental result, we also check whether the NLO-KF is still showing the good results, and we found out that it is very close to the ground truth measurement,
and we finally we check with the experiment of robots, which the surroundings are trees and also some buildings, and these robots can navigate and also can autonomously move in this environment with some kind of distortion of GNSS measurement. And this work has been published in Journal of Measurements, and this is the Q1 journal with the 1.24 SJR points. So here we combine the GNSS sensors and also the inertial measurement, and it shows that under this canopy, the robots are still working well, but we need to check with a more dense canopy for yeah, whether this method still can work in the agricultural area. And then we also, besides sensor fusion, we also explore the image-based navigation. So by using vision, the robot can follow path even when the GNSS is unavailable. To ensure safety, we apply the Lyapunov barrier functions, which guarantees that the robot's motion constraints and also avoid the unsafe trajectories. This is particularly important for structured agricultural fields. So here is the simulation of the constrained motion, where the quadrator here remains stable and safe even when constraints are applied, and also some the constraints of the vision of the quadrator are limited. So this demonstrates that the Lyapunov-based control can guide the robot while respecting field boundaries and safety zones. So here is the preliminary results of the Lyapunov barrier function control. So the camera is from the quadrator, and it can find the target without losing the target during the motion. So this also preliminary result has been presented at the International Conference on Instrumentation, Control, and Automation, and we hope that this work will be further be published in a journal publication. So in summary, this research contributes to robust localization and safe navigation for agricultural robots operating under dense canopy conditions. So by combining sensor fusion and image-based navigation and also constraint control, we are moving closer to reliable deployment in real agricultural environments. I would like to sincerely thank to the Asahi Glas Foundation for their generous support of this project, and I thank you all for your attention. I look forward to your question. Thank you very much.
Okay, thank you very much, Dr. Augie, for the presentation. So now I'm welcoming questions from the floors. If any questions from the floor for Dr. Augie's presentation?
Yeah, thank you, Augie, for your nice presentation. I would like to ask a short question. So how do you find the parameters of your unscented Kalman filter? Is it by like mathematical estimation or something, or is like iteratively getting the parameter? So how do you define that?
Okay, thank you very much for your question. Yeah, the parameters is determined by doing some optimization, and we are collecting the results and then do some optimization on the parameter determination.
Okay. Any other questions? We still have several minutes left. Any questions from the floor? Okay, maybe I have one question, Pak. So yeah, it's very interesting to know that yeah, there's a robot that can work under a canopy, and my questions is usually you're working in the field, especially in yeah under canopy in the forest area or agriculture area, we have problems with humidity and temperature. So does it affecting like this research and yeah how to consider about that these factors?
Yeah, for the humidity and also environmental conditions, probably the GNSS, yeah, the signal from the GNSS will distracted by the environment like that. But yeah, actually we combine with the differential GNSS, so it means that we have a kind of a stationary stationary set GNSS. And then also we can correct the um, yeah the disturbances from the environment while using the differential GNSS.
Okay. Thank you. Is that any more questions from the floor? Okay, if there's no more questions, please give biggest applause for Dr. Augie. Thank you very much. Okay, and next I would like to invite our second speaker for today, Professor Hendra Grandis, with the topics of regional prospecting for hydrocarbon in a frontier area from integrated gravity and magnetotelluric methods in Atambua, West Timor, Indonesia.
Okay, good afternoon, ladies and gentlemen. I'm a little bit nervous because being the oldest guy in the room seems like the first time. So this is our research with my colleague from Faculty of Earth Science and Technology, Professor Prihadi Semintadireja. The term frontier is, in fact, is far from the usual area where we can find oil and gas. So this is my outline, and allow me to use this quote. It is a very famous quote that with great power comes great responsibility. Maybe all of us already know that. But in our case, with complex geology comes vast potential for natural resources. And don't forget that the other side of the coin, we have also a potential of hazard or disaster. Okay, this is Timor Island. Timor Island, and there is this complex geology of Timor Island is the result of northward movement of the Australian continent colliding with eastern part of Eurasian plate, and then in the east, northeast, we have Pacific plate with relative movement to the east, to the west. So especially we have more complex area in Banda area here. So this is the shows of oil and gas possibility in this area. We have many oil ship and also gas ship. We have also in our neighbor Timor-Leste similar situation, similar feature, because geological feature do not know about the country boundary. So, sorry. The one well known here is the this is the only oil, gas and gas producing area. It's become Timor-Leste ownership. Now we try to expose to add more data in western part of this island. So the data is very limited there because the complex geology means also rough topography where seismic method that is usually used for oil and gas exploration cannot go there. Yeah. And the data is blurred because the seismic wave is dispersed because the complexity of the geology. So with our research, we would like to add more data, especially the subsurface data from geophysics method. We have gravity and magnetotellurics in with a hope that we can provide more data and then can guide further exploration effort in this area. So, few words about gravity. We have a small variation of gravity field that can be used to infer the subsurface density distribution. So we usually process the data to enhance particular feature, for example, lineament and others. And then we can also have a model, 3D model, representing distribution of density of the subsurface, and then we interpret them as geological structures and also geological formation. In magnetotellurics, we do the same way, but we use natural electromagnetic signal. So we have to deploy only receivers in the area. Then we record the natural electromagnetic field variation. So this is the part of our student works from Lemigas, Oil and Gas Center in Jakarta, part of Ministry of Energy and Mineral Resources. They deploy almost 1,000 gravity and magnetic station and 200 empty sounding there. So we try to collect data and then interpret the result. So with gravity, we can delineate two main basin in the area, Central Basin and Atambua Basin, which are already known by geology, but with different size, different extent, lateral extent. So with our result, we have here smaller Central Basin and relatively larger Atambua Basin. That was, they are not known the exact size from geology. And more quantitative interpretation from the gravity, we have 3D modeling. And with this result, we can differentiate sedimentary layers above sediment and basement. With MT, we have two-dimensional modeling that constrain the depth from gravity that usually have more ambiguity. So this is the main profiles, main slice, a similar 3D model for the density, but we slice it into three main profiles here. And then the interpretation is that we have sedimentary layers that extend to this area, different layers, different density that is well correlated with actual geology of the area. And from magnetotellurics, we have also differentiation even between even in from the same layers
we have different sequence that is related to the age of the formation. So with these results, we hope that we can supply the geology for refining their models. So once again, we have main basins identified and also several formation in the basin infill. So since this is the first part of our work has been published, so we try to manage to publish more after this research. So we would like to integrate all of the results to publish more. And thank you for your attention. And I would like to add one slide. Yeah, our neighbor in the East Timor or Timor Leste have done the same things. Yeah, they have gravity gravity measurement, but from the air, so airborne gravity. And the next step, they ask our team to do magnetotellurics measurement in their area because seismic does not work also in this area since we have a complex geology. Thank you very much.
Thank you very much, Professor, for the presentations. Okay, so yeah, I believe that it's a hard time during the day after the lunch, but hopefully these interesting presentations can wake us. Okay, so is there any question from the floor for today's presentations? Any questions? Okay. Yeah, so Professor, probably because yeah, I'm not a geologist, but I believe this is a very interesting work. Probably you can explain a bit to us about the methodology itself. So you mentioning about stations, magnetic stations. So is it we measuring under the ground, and maybe probably a little explanations about how it works to measure until certain depth. Maybe
Okay.
that's my curiosity.
Yeah.
Thank you.
So basically, geophysical method works in the surface. So we observe electromagnetic field, natural electromagnetic field without injecting nothing. Yeah. We observe natural electromagnetic field in the surface. We have electrodes and magnetometer coil magnetometers, and the signal itself is generated by the sun activity of the sun here. We have relatively very small Earth here, then the activity is very large here. So they push a solar wind that perturb our magnetic field. So the variation of the magnetic field generate electric field in the Earth. So it's kind of chicken and egg. We do not know what is the first. Yeah, electric generate magnetic, magnetic generate electric, but this phenomena depends on the conductivity of the subsurface of the medium. So with observing electromagnetic field, we can know about the conductivity or resistivity of the subsurface, and then I'm not the geologist neither, though we discuss with the geologist to interpret the results. Okay.
How much depth can you get the information?
Okay.
Yeah.
Yeah. Theoretically, we can investigate any depth because the depth penetration depends on the frequency or the period. So the longer period, we have a deeper penetration, but of course we have a lower resolution. So, my colleague in France used this kind of measurement for more fundamental research that can reach upper mantle, something like that. But the observation we have to be in years, so it's not very practical in Indonesia. Okay, thank you
Thank
very
you.
much.
Okay. Is there any other questions? Okay.
Okay, thank you, Mr. Hendra. Such an interesting presentations. I have a bit questions about the basin that you use two methods of geophysics,
Yes.
MT and gravity.
Mhm.
So you mentioned that you have found two basin called Bano Basin and, if I'm not mistaken, Central Basin. So my background is geology as well.
Okay.
So as what I know, that already published some formal basin for oil and gas in Indonesia. Is it your new finding, or or just to validate the existing one? Thank
Okay.
you.
Okay, thank you. So it is correct that we have it is published by the ministry team, yeah, about the possible basins for hydrocarbon resources. Uh, in our knowledge, that this basin uh, defined differently from the geology, because the geology said that the Central Basin is larger than the Atambua Basin, while our finding is the inverse. So it is, in our opinion, it was more quantitative, especially we add about the differentiation in the layering between the sediment and the basement. Thank you for the question.
Okay, thank you very much. So yeah, I believe there's still many questions in your mind, but unfortunately the time is up. So please give a big applause for
Thank you
Professor
very much.
Hendra. Thank you. Next, I would like to invite the next speaker. We have Dr. Dani with the titles of the presentations and investigations into the health effects of transit-oriented air, analyzing accessibility, air quality, and equity factors.
Okay. Yes, the slide is on. Good afternoon, everyone. My name is Gusti Ayu Andani, and you can call me Amdani. So today I'll be presenting our study entitled Quality of Life in Transit-Oriented and non-transit areas, evidence from Jakarta. Well, the title is adjusted a bit from the research title to mainly reflect the main content of this study. But first of all, I would like to thank Asahi Foundation, Dr. Naoki Sugimoto, as well as Professor Al-Fahmi from the RE ITB for supporting this research. So this work was conducted under the School of Architecture, Planning and Policy Development, Bandung Institute of Technology, together with my colleague Anissa Alivia Suhartono, but unfortunately she couldn't come today. Let me start with some background. So according to Jakarta in Figures 2024, the ratio of motor vehicles, as you can see in the text here, is 2 to 1. So imagine every one person in Jakarta has two motor vehicles. And as you also know that people who work in Jakarta do not only live in Jakarta, right? They live in Bekasi, Tangerang, even Bogor. So they come to Jakarta to work. So you can imagine like how congested it is there. So this massive growth has triggered a range of problems, not only traffic congestion, but also declining environmental quality, air pollution, emergence of slum areas, and deteriorating of public health. So as a result, the air quality index is very low. So it's around 86.92. So it is very low. So this condition underline the urgency to rethink how our urban and transport system shapes residents' well-being. Oh yeah, this one. Okay, so uh, transit-oriented development, maybe some of you already familiar with this concept. This is a concept that is widely promoted to tackle these challenges. So as you can see in this slide, there are several key principles of transit-oriented development. For example, proximity to transit hubs, and then mixed land uses, compact land uses, high density, pedestrian and cyclist friendly environments, reduce car dependence, inclusive public spaces, and importantly, a more sustainable urban model. While these principles are acknowledged in Jakarta's planning documents, the actual application remains fragmented and also inconsistent. A simple example, uh, there are two pictures there. So this picture, as you can see on the slide, it shows parking facilities that can be found right in front of the MRT stations. So imagine if you travel, use the MRT, and then right in front of the MRT stations, you can see the parking facilities. So this is actually undermines the walkability goal. Instead of walking, people can just use the car or even motorcycles. So this is not the TOD principles that we would like to implement actually. So this research, yeah. So our research focuses on residents who live or work in five TOD areas. Duku Atas, Duku Atas, and then Fatmawati, Lebak Bulus, Blok M Sisinga Mangaraja, and Istora Senayan. So we look at people living or working within 450 to 850 meters of each TOD centers. And for the sake of comparison, we also examine residents who live outside TOD areas to compare their quality of life in TOD areas and also in non-TOD areas. So our objective are threefold. The first one is to examine the relationship between TOD and residents' quality of life. Second one is to identify which factors most strongly influence the quality of life in TOD areas. And the last one is to analyze how accessibility, social interaction, as well as urban design contribute to overall well-being. So we operationalize the quality of life using WHOKOL, BRIEF framework. So this framework actually means that we considered four aspects. Physical health, such as self-reported health status, physical activity and commuting habits, and then psychological well-being, including perception of safety, comfort, happiness and stress, and social relationships such as participation in community life, and satisfaction with interaction. And the last one is environmental perceptions, which are air quality, noise, temperature, public spaces, and safety for pedestrian and cyclists. Okay, so we found, yeah, our study involved 413 respondents. So using exploratory factor analysis, we identified there are six latent variables or six latent constructs, which together can explain 72% of total variance. So this actually provided a robust basis for examining the factors that matter most to residents' quality of life. Also in this table, yeah, uh, this is the basic statistics that show that in general, residents who live in TOD areas have higher score in quality of life. But the question is how and why? Why they are being more happier than the others? Uh, We examine the predictors affecting the overall quality of life in TOD areas and non-TOD areas. So our findings show quite clear contrast. In TOD areas, satisfaction with facilities and mobility are the strongest predictors of quality of life. Residents actually value infrastructure like transport station, pedestrian pathways, and then commercial amenities, public services. So this reinforce the idea that TOD delivers value through accessibility and service and transport service provision. On the other hand, in TOD, in non-TOD areas, environmental satisfaction and individual well-being are the most influential factors. Here, for example, air quality, noise, safety, and green spaces matter more, since transport integration and mobility benefits are weaker. But we have quite interesting result. As you can see here, the social interaction was found not significant in both conditions. So it means that social interaction and activities were uh, not very important in both settings. So I guess this is a common phenomenon in big cities, that social aspect is no longer quite essential. Yeah. Okay. So to conclude, since we have only maximum of 8 slides, to conclude, TOD characteristics such as proximity to MRT stations, walkability, and mixed land use do enhance accessibility and mobility, and in turn improve certain domains of quality of life. However, our study also indicates possible residential self-selection. So this means that people who prefer, for example, to use public transport are more likely to choose to live in TOD areas. Meanwhile, those who prefer to use private transport tend to live elsewhere outside the TOD areas. So this means planning strategies should be differentiated. TOD areas need policies to ensure affordability and inclusivity. Otherwise, they risk becoming enclaves for higher income, better educated residents, and therefore deepening spatial inequalities. And as I mentioned before, in this research, we also found that social relationships are not automatically improved by TOD design. So physical infrastructure should be complemented with initiatives that actively foster community engagement, such as programming in public spaces, supporting local businesses, and participatory neighborhood planning. Last one, we recommend future research to use longitudinal data, since here we use cross-sectional data to collect data in one-time survey. So this longitudinal data is important to see how quality of life evolves over time and to integrate broader measures of social capital and equity. So yes, finally, last one, this research output has been accepted, so not yet published. I received an email a few days ago that this research has been accepted in the International Journal of Urban Sciences. So yeah, I hope it can be published soon. So thank you very much for your attention, and I look forward for your questions and discussion. Thank you.
You very much for this very interesting presentations. Okay, so again, I would like to open the questions. If there's any questions for today's these presentations. Please.
Well, thank you very much for the nice research, right? So for me, it's very interesting as well because we have the OD area here. It's also in Bandung, right? But I'm wondering, how do you measure? How did you measure the quality of life? As we know that the quality of life is very, how do you call it, hard to measure, right? Because it's qualitatively, I think the quality of life by person is could be different, right? So you have the QOL domain, right? But I think it's in my knowledge, maybe it cannot cover all parameters. So maybe you have any ideas how to really have the validated data of key of life close to the real condition actually. Quality, that's its quality, right? Maybe we don't know if someone is so small, for example, maybe we think this the quality is good, but actually not, right? So could you little elaborate it for this one? Thank you very much.
Uh, oh yeah, I would like to show you this slide then. This will help me to answer. So thank you, Professor Alframi, for your questions. Uh, we actually took a couple of months to finally decide on how we should measure the quality of life. Because, for example, there are a lot of frameworks on how to measure the quality of life. But then we decide to use the framework from WHO. There are so WHO published two types of framework. The first one is the complete one. There are 100 indicators, and the short one is 26. I took the short one. So I took the short one because otherwise, because if we use the 100 indicators, then the respondents will be exhausted to answer the questions. Like I mentioned before, this is the weakness of doing cross-sectional survey. uh, uh, we have only 26 indicators. Although we use 26 indicators, the indicators is evolving. So at the end of the questionnaire formulation, we have uh, almost 50 indicators. So those indicators covers four aspects: physical health, psychological well-being, social relationship, and also environmental perceptions. So in physical health, for example, we formulate uh, some kind of statements. So for example, I feel healthy than before. Uh, I uh, I never feel sick, or I never feel um difficult to breathe, for example. So we formulate certain statements, and then the respondent will answer using Likert scale, 1 to 5, if they are very disagree or very agree to those statements. But like you mentioned before, this is quite subjective. This is very subjective. This is actually the weakness of using Likert scale or perception study. Uh, so in the future, we actually recommend like for example, one respondent can answer 4 if they are feeling very healthy, or they are feeling uh, so great, for example. But the other respondents could answer 5 if they are feeling healthy, or they are feeling great, right? So so this type of weakness of perception study. Uh, as we recognize this as our weakness actually. But this one should be conducted. Otherwise, it will not. This never been. This is will never be conducted. Instead of doing perception study, we can actually do some kind of direct measurement. Direct measurement on the health condition, on the air quality, for instance, using uh, the right tool to really measure about the pollution components. So this type of study should be combined with science, with the not this is type of social science. This type of study should be combined with uh, yeah, health science, I think. Yeah, to complement this study. Yeah, I hope I will I answer your questions.
Okay, thank you so much, Dr. Andani. So unfortunately, the time is up, but I believe there's a lot of room for moving forward with this interesting research. Okay, so please give your biggest applause for Dr. Andani. Thank you. Okay, so next, I would like to invite the next speaker, Professor Dr. Sri Mariati, with the title of Sustainability Water Reuse for Mid-Sized City, Scheme Drivers Barriers.
Yes, good afternoon, ladies and gentlemen. So we would like to present our research funded by Asahi Glass Foundation. For that, we thank you very much. And also, good afternoon, Bapak Direktur, Pak Al-Fahmi. So the title of our research is Sustainable Water Use for Mid-sized Cities, Scheme, Driver, and Barriers. And this is our team. I myself, Sri Mariati, and then Dr. Dia Wulandari Putri, Dr. Anindriana Stiti, and also Ibu Igusti Ayu Andani. And also we have our doctoral researcher, Ibu Vika. All of us come from Research Center for Infrastructure and Regional Development, Institut Teknologi Bandung. It consists of two faculties, School of Architecture, Planning and Policy Development, and Faculty of Civil and Environmental Engineering. So the background of our research is that all of us maybe realize that water is very important for our life, but the problem is actually the water it's maybe more than the land. The water compared to the land area is more all over the world, but the problem is we cannot use all of the kind of water. For example, seawater and also rainwater, it's very limited. So that's why because of the need for the water, and let's say in the quote the availability of water is very limited. This is the background of our research, and then maybe we think that water use is very important for the future. And then we explored the previous study. We realized that most of the study explored the big city, for example, Jakarta in Indonesia, and also some big cities in other words. And also in another side is in rural area. Whereas the area like mid-sized city is less developed, the study for the mid-sized city. Later we will explain why the size of the city is matter in terms of water use. So the goals and the objective of the research is to explore the scheme, driver, and barriers to sustainable water use for mid-sized city. And then we employ two main methods. That is, we use a qualitative research by using primary data with interview with the key stakeholder for water use, and we implement coding system to identify barrier and also potential for water use. And then we also employ quantitative methods, especially for evaluate the water use scheme based on the cost in this research. Our evaluation method is cost and the number of water production from wastewater and rainwater. So we can see from the figure over there. So basically what we explore in this study is we examine the possibility for water use, which one is the best one between wastewater and rainwater. And then we also evaluate the scheme, not the scheme, the scale, whether this is building or household or communal size or in city size. So in the next slide, we identify why the city size matter for the water use. We identified three scale of the city, large city, medium city, for example, Cirebon, our case in Cirebon, and then small city. This is the population range for its category of the city, and also the population density. And the most important thing that maybe influence the water use scheme is the land use, where in the large city maybe many service sector like offices that need to, or apartment, like in Jakarta. We also have a study in Jakarta, many potential demand that need to implement water use because the price of water is very high in Jakarta. And also the potential for water use, very high because of the dense water demand as our exploration, like office, and also the office building and commercial. It's they need not very high quality of water, but the important one is the quantity. So this is the rationale for the our study to explore the medium city or mid-size city. Large city is there are many study explore the water use for large city and also for small city or rural area. But for medium city or mid-size city is very limited. We use Cirebon city as one of the medium city in Indonesia because the number of population is around 350,000 in Cirebon city, and Cirebon city consists of 5 district: Harjamukti, Lemah Wungkuk, Pekalipan, Kesambi, and Kejaksaan. This is we can see here the number of population for its district, also the area, population density, and average water consumption based on the data. And then wastewater infrastructure, existing wastewater infrastructure. We can see here actually the wastewater treatment plant has already there, but only for a certain community, for communal size. For example, in Harjamukti, there are two wastewater treatment plant, Glatik and Rinjani. And we can see here that the comparison between design capacity and production capacity is the comparison is very high. I mean, there are still many capacity that that have not been used, the idle capacity. Also in Lemah Wungkuk and Kejaksaan, there are two districts that have not have the wastewater treatment plant in communal scale. Yes, based on our calculation for the as the slide before, we implement the quantitative approach based on the evaluation of the cost and the water use production from wastewater in the next slide, and from rainwater. Yeah, the upper table is the water use potential from wastewater, and the below one is a water use potential from rainwater. And we maybe we can see from the last two column for wastewater production and also for the cost, also for the rainwater potential, for the runoff, or the rainwater that can be captured for the reuse, and also the cost. Yes, to simplify, we make this in the form of diagram in the next slide. So maybe we can see here in the to help us, to identify how is or how are the comparison between wastewater production and cost in communal and city size and city scale. Of course, if we compare city scale and communal, because of the economies of scale, of course, that the city scale infrastructure is lower cost compared to communal one. But the problem is the infrastructure have not been in place, yeah, for the city scale. So the infrastructure is only in the available infrastructure for wastewater treatment is only in the communal scale, and we have limited information. I mean, limited information about the building or household in Cirebon that have been implemented the wastewater reuse, yeah, or also rainwater harvesting. So this is the evaluation of the production or the volume of the water use from wastewater and from the rainwater. And then in the next slide, we also identified the driver and barrier for wastewater and also rainwater reuse, yeah, based on our interview with the key stakeholder, mainly from the government. And we can see here that for wastewater, the driver mainly related to the shortage of water in certain district. Cirebon, it's get the water, yeah, clean water from Kuningan actually. So there is no source of water in Cirebon. And then the existing wastewater infrastructure has have already in place, and then cost efficiency potential for communal and city scale system, and also there is the need to support the environmental sustainability by reducing untreated wastewater discharge. And for rainwater harvesting, the driver is high rainfall intensity during certain month, and also can reduce dependency on public water supply, and low cost infrastructure for rooftop or community scale collection, and encourage green initiative and sustainable urban development. So from the government itself, there is also their willingness, yeah, to implement the green initiative in their program. That is the driver, and then the barrier for wastewater is limited treatment capacity of existing wastewater treatment plant, high capital cost for upgrading wastewater treatment plant, and then the most important thing is social acceptance. We also find here in Jakarta also social acceptance. There is a problem, and limited off-taker for treated water, especially in private or household sector. This is the characteristic of medium or mid-sized city. And then for rainwater harvesting, we know that especially now because of the climate change, we don't know exactly when the rainwater will come. Yeah, so there is a seasonal variability. There is no this is not, we don't uncertainty, yeah, about the volume of rainwater, and then require space for storage tank, initial installation cost also, if we would like to implement in the household scale, and water quality concern. We come to the conclusion by comparing these two findings from the scheme and also from the driver and barrier. So the implementation strategy, we can be divided into short term and long term. For short term, we encourage to apply wastewater use at household and communal scale in area with existing wastewater treatment plant. And also in the long term, integrate city scale rainwater harvesting, because this is low cost. If the scale higher, then the cost will decrease with wastewater use for sustainability and cost efficiency. And then we also identified the district that can be prioritized for the implementation of the infrastructure. For the short term, Harjamukti, Lemah Wungkuk, and Kejaksan, and for the medium to long term, Pekalipan and Kesambi. And we also identified urban planning implication. We have to also consider the population density and water consumption pattern for maximum efficiency and coverage. That's all from us. And again, we would like to thanks for Asahi Glass Foundation for funded this research, and also from Directorate Research and Inovasi, Pak El Fahmi. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor Sri, for the presentations. Are there any questions for Professor Sri presentations? Any questions? Okay. Thank you.
Well, thank you very much for nice presentation, but Sri. I a little bit would like to clarify for the reuse. That's mean for the drinking purposes or for the other purposes, for example, because the quality of waters can be different, right? And also the quality of wastewaters. Wastewaters also can be very, let's say, wastewater with the very dirty ones. I mean, with the big contaminant, for example. So we need something to treatment it, and then there is also rainfall and water, for example, right? Can be also different, depend on the environment as well. So could you a little bit elaborate it in this one?
Yes, thank you,
very much.
Pak El Fahmi. So until now, I think most of the country, not only in Indonesia, but in Indonesia, the water use is limited for not for drinking purposes, but for like gardening, watering the plant, or for cleaning. So the quality of water is not too high. And for example, in Jakarta, it's only to treat the water so that it can be used for cleaning purposes. So not the drinking quality, not to come to drinking quality. And also for this one in Cirebon, also the wastewater treatment plant is are there, yeah, but it's only to give the treatment, yeah, and then it need to dispose the water into water body. Yeah, meanwhile, yeah, but we propose how about if we not to make the water goes to the water body, but we use, yeah, as the principle of also in solid waste, yeah, everything that not to dispose, yeah, to the environment, but we use, yeah, before, yeah, also the principle of this research, yeah, but not to come to the drinking or clean clean water for drinking.
Thank you. Okay, thank you very much. And please give once more applause for Professor Sri, because this is the time is up. So thank you. And I would like to invite the next presenter, Dr. Eko Agus Plastio, which today couldn't make by himself, so will be represented by Fitriani Agustin. Yeah. Okay, so the titles of presentations is Earthquake Disaster and Economic Impact Assessment toward Sustainability Cities and Communities. Oh.
Check. Okay. Thank you very much. Good afternoon, everyone. Ladies and gentlemen, I'm on behalf of Pak Eko, Dr. Eko. He is here, but he just me to present our work. So my name is Fitriani Agustin. You can call me Fitri. I'm a member research of earthquake disaster and economic impact assessment towards sustainable cities and communities, a case study of South Jakarta District, Indonesia. Before I'm going to present, we would like to thank for the Asahi Mr. Naoki Sugimoto, and also Professor Fahmi from Research and Inovasi ITB. Okay, first of all, our research, please next. Okay, so our research area is in the Greater Jakarta area. We know that Jakarta has faced significant earthquake risk due to its geographic positions. So we know that the megathrust in the subduction zone in the southern part of Java Island. And also some island active fault come through this city, especially in the southern part of Jakarta. And this is significant while Jakarta is have a densely populated area also, and have a massive robust infrastructure, and the economic growth city will significantly impacted. So Jakarta economic show that the robust year growth on 4.95% for the first quarter of 2025, means this year. So it's primarily supported by service and financial sectors, and remains vulnerable for the earthquake disaster. So these potential seismic events of the city, it's become the great factor for the Jakarta's development. So we try to overlook and to assess the city preparedness, overlook this factor. So in terms of economic vulnerability, so we focus on susceptibility, I apologize, buildings and business assets to damage of destructive earthquake. Okay, next. So for the materials and methods, we use two methods, earthquake risk scenario, and to assess the seismic hazard. So we use some physical, okay. We use some physical parameters. For example, this the geological map. So it and for now the vulnerability of the soil and the rocks in the Jakarta area. And we also use second methods is economic impact scenario to evaluate potential loss in productive business sector. So our focus study is in the southern Jakarta, partially specifically in Kemayoran Baru, where lots of business sectors there, and we also focus uh, in the business sector, mainly in the service, service. And the Baribis fault, as we may know, some of us have recognized their activity some few days ago, So it's this segment in Purwakarta and Bekasi. So it's come through this southern of Jakarta. So we focus on this fault segments. So our data is used from secondary data and the economic and the primary record data from interviews. So we use direct interviews from the figure in the South Jakarta, mainly in the service-based business. Okay. For the earthquake risk scenario, we use the for the technical to produce the map is the earthquake hazard map. So we use peak ground acceleration or PGA. It is common methods in the earth sciences, mainly in the seismologists as well geologists. So we use the parameter of 500 years return periods, mean we have probability of 500 years, because until now we cannot predict the earthquake itself. So by this parameter we produce the earthquake hazard index map, So scale from 0 to 1. So categorize as low, medium, and high. So this one then overlay with the business asset vulnerability maps, which represent the distribution of value business asset based on their construction cost. And to value the buildings, we use some of the standardized from the PUPR, Ministry of Public Work, for the construction. And we use spatial analysis to overlay all these parameters. Okay, next. Here are the result. So from this, the earthquake risk scenario, we produce okay, earthquake hazard map. So it's scale from zero to 1. So we know that the lower hazard index is 0.2, is concentrate in the northeastern, yeah, in northeastern is here. So and the highest value is 0.5, concentrate in the southern region. So it's near Cilandak border, where the central business districts are many here. And most district has moderate to peak ground acceleration, means that it's lower to mid-range hazard in terms of hazard risk map. And this one also, we assess the seismic hazard variation is linked to the geological or the lithological, because it's consists of unconsolidated materials which amplify the seismic wave. So will contribute to the high impact for the earthquake itself, to the infrastructure. Then for the earthquake risk scenario, we overlay uh, the earthquake risk map. We overlay with the 214 business assets. So we use geospatial analysis, concentrate in the service base, mainly IT services, law firms, finance, healthcare, and retails. So our assets value, this asset business value range from 120 billion to 2.8 trillions, yeah, in terms of building assets. And we also concentrate in the north and southern part of Kemayoran Baru, where's the highest risk there, according to our maps. Okay, so the highest risk area is concentrate in the southern part, and indexing from 0.2 to 0.7. So the higher value indicating greater risk to economic asset. Okay, that's from the earthquake risk scenario. So the second method is economic impact scenario. We would like to know that the how this earthquake impact to the economic losses for these 5 categories of business. So EIS actually evaluate the economic consequence of an earthquake through both qualitative and quantitative methods. So for the qualitative method, we focus on I'm sorry. Oh, sorry. We apologize for that. Can okay. Can we back from? Okay. For this qualitative scenario, we use the secondary data from the kantor pajak di Jakarta Selatan, in South Jakarta. So the information, so the key for the component is how their business interrupt when the earthquake occur in the area. So we use the business asset value losses and construction costs. this one back. Economy. Okay. Uh, okay, we apologize for this. So for the qualitative analysis, we focus on indirect business interruption. So using secondary data, we have GRDP. It's a regional gross national product from 2014 to 2024, and primary data from the interviews of some owners of the business service. Yeah. So our finding that we estimate uh, okay, for the quantitative, we estimate the cost of construction for damage in the commercial buildings that we already collected from 214 assets, especially in Kebayoran Baru. Okay, so our finding found that for the business interruption in qualitatively, so we are our result shows that in terms of indirect business interruptions, the business service could not directly affected for their business running. So our data shows that it's only affected in the COVID, yeah, so 2021, and the major flood in Jakarta. So other years, they can still run smoothly. So during okay, we would like to say that they only affected it during major flooding. But surprisingly, during COVID, they cannot. They don't. Okay, when I say, so it's not interrupt their business, yeah, because even for lockdown and restriction for the business service like IT, insurance, financial, they use the technology, so they don't affected by the COVID. And for the interview from the corporate service, we have three interview for the business owner in IT service and insurance. So significantly is affected disaster event. So primarily lose limited to access the minor damage for the work. So it just only affect the equipments and because they
Sorry,
use the technology.
1 minute left.
Okay, okay. So next. So this is the quantitative analysis. So we use the standard from the PUPR. So the estimation cost we calculate here. So it's the from the lowest. So the damage itself is for reconstruction. So the business asset can affect it for the building owners because all the business service is all tenant. So they don't have a risk for the damage assessment. I mean the damage during the earthquake. Okay. So our conclusion, this study is very early because we combine the physical aspect from the earthquake risk map and the business losses. So we understanding that we will enhance understanding of economic risk distribution. So it's contribute to the urban risk assessment and also the disaster economic. And we can give the overview of the many hazard such as flood and also other things, so not only from the earthquake. And we can also broaden our research not for the for the business service, but also the small medium enterprise and other informal sectors. So this is our disclaimer is very early research. So for the further research, we can expand the hazard scope and also give the have the user-friendly geospatial tools just to estimate the risk of the every buildings or any business and any hazard. So hopefully our future work will can going in the next future. Thank you. Thank you, Asahi Glas and ITB. Thanks.
Thank you very much. And I would like to invite Dr. Eko. Probably there's some words that will be added.
Okay, just 2 minutes. First of all, I'd like to thank Pa El Fahmi for this and also from Asahi Glass again. I just came to the inauguration of the, so I'm not really ready to make a presentation. But anyway, thank you. First of all, I'd like to also to say that this research is a collaboration effort between SBM ITB for the business part and with BRIN, which is research Indonesian Research Agency, Innovation Research Agency, and also Ministry Geological Agency, Ministry of Energy and Mineral Resources. So this is a collaborative effort once again, and it is in our best knowledge, it is first effort to combine between technical and business perspective, try to combine it in a way, albeit it is still quite preliminary, so we need for further research for make it more meaningful. But again, thank you for the opportunity and for the funding. I would like to thank also my team from different. It's actually she's not from ACB. She's from Ministry of Energy and Mineral Resources. Yeah. Also Pak Pandu and also Bu Yukni. Also they are from different institutions. Thank you very much.
Okay. Thank you very much for the presentations. Unfortunately, we have no more time left. So if you have any questions, you can come directly to Dr. Eko or to Ms. Fitriani. Okay, next, I would like to invite our next presenter, Dr. Engpri Hermawan. Okay, with the research titles is Collaborative Involvement of Sustainability Tourism.
Okay, good afternoon, esteemed ladies and gentlemen. So, I'm here on behalf of Dr. Eng Pri Hermawan, STMT, because cannot attend our meetings today. So, I am Raffi Indari Arianto, one of his research assistants. Will present about the collaborative involvement of sustainable tourism, capturing and analyzing dilemmatic situations in tourism village. And once again, we would like to thank Asahi Glass Foundations for they have provided the research funding for our research so that I can stand here to present our works. Okay, so this is our team. So the first one is of course our lead researcher, Dr. Eng Pri Hermawan STMT, and then there is Made Citra Yunias Tuti SAMM, and then me myself, Rafindari Arianto STMSM, and Krista Fiarildila Suryanto STMSM. Okay, so this is our research background. So we know that in Indonesia, we still have centralized fossil energy, especially when we are considering the levelized cost of energy or LCOE. The lowest LCOE in Indonesia is still on coal energy. So that's why Indonesia still Okay, so that's why Indonesia is still rely heavily on fossil energy because yeah, that's still the cheapest source of energy that can be feasibly used by the populations. Especially this will also entails a more centralized electricity generations based on this fossil energy. As we know that we are also having the urgency to make our earth system more sustainable, we need to also transitions to the renewable and sustainable energy. And so that's why we are looking at another options of doing transitions into the renewable energies. that's based on the community. So this is um, maybe we can call it as a distributed electrical energy generations, as it is more community based. So small scale community based renewables can provide access to affordable electricity, ensure long term stability and control over their energy supply, and promote more sustainability community along with local job creations. So energy will always entails to job creations and economic growth. And then also this is a solutions for rural poverties, because if we rely heavily on centralized fossil energy, then geographical barriers will still be a problem for uh, rural people, rural citizens, especially that is far away from the center of the fossil energy generations. So yeah, community renewable energy is gradually regarded as solutions to alleviating rural energy poverty in developing countries, because we can have a closer energy source which can be generated with solar PV or with wind energy with the one that use it. So for Indonesian's context, we have 25 million people lack electricity because of the remoteness and the outer islands. And then in 2022, we have 67.2% of coal, as I have mentioned before, and only 20.3% renewable energy in electricity generation. So I think this, uh, sorry, 12.3. So this 12.3, I think, has already included with the water-based generation system with water dam. And then grid expansions impractical for archipelagic regions. So distributed generations can serve as an alternative. So this is also a potential for desa wisata or tourism villages to adopt renewable energy. So why we choose tourism villages? Because in tourism industry itself, it is still has a high demand for electricity, especially if we are talking about water. So maybe we there is for our case, we use the case study of a beach area for the tourism villages. Yeah, there is water near the beach, but as some have mentioned before, it is not readily available. So it still needs to be pumped out of the soil. So that still needs some electricity energy. And then we have some legal framework for the sustainable tourism and renewable energy transitions in tourism context, like law number 10 in 2009 with sustainable community-based tourism, and then law number 6 in 2014 with village empowerment, and then regulations number 13 in 2020, CHSE standard including energy efficiency in tourism. And then tourism villages also has a strong potential for renewable energy adoptions and also aligns with sustainable tourism, local empowerment, and environmental. So this is also with the fact that the central energy supply, which is supplied by the government-owned company, is still not really that reliable. So what we have found in our case is that they still can have some blackouts within maybe a full day without electricity, and that's a bad thing for any business. Okay, and then we have this research gap. So limited research on social acceptance of distributed generations, be it the socio-political, community, and market. And then some renewable energy projects failed due to weak stakeholder support and neglect of social dynamics. So for our research objective to answer those research gap is to explore applications of renewable energy in rural tourism ecosystem, and then investigate stakeholders' dilemmas in developing renewable energy for rural tourism, and test a realistic decision-making model for renewable energy in rural tourism using system dynamics. So this is our methodology. So this is our framework, research framework. That is also the extensions of our past research that is also being funded by Asahi Glas Foundations in Palembang. So we can see that our modeling approach start with identifying and consulting with the stakeholder, and then we model the actor interactions, and then we do the dilemma analysis and identify potential collaborations that can happen within those interactions. And then we also model the system of system interactions because we have both the societal system and then the environmental system. So in conflict research or collaboration research, we have what we call the dichotomous factors that can be categorized as factors that is endogenous or within the conflict itself, and the factors that is exogenous of the conflict, so outside of the conflict. So if we are talking about endogenous conflict factors, we are talking about how two or more actors have differences in their preferences. So that's what creates a conflicting situations. Or maybe we can also see it as a potential collaborations. But when we say about the exogenous factors, we also say about the environmental pressure, like if we are talking about the mandatory renewable energy mix, that's what we have found in our past research in Palembang. That's what makes the conflict that can be sharpened or maybe more intense. So that's the exogenous part. And then as we are talking about tourism, we are also talking about a business model. So a business model, we will have so business model, we want to overlay the system dynamics model into onto the business model canvas. So for this, we have the main point is in this attractiveness, because tourism rely heavily on the attractiveness of the spot. That is also based on the scenery itself and the potential of developing it into an edutourism on the hybrid renewable energy facility. And then this is for the dilemma analysis. So currently the community is facing a hard time in maintaining the hybrid renewable energy because of the continuous decreasing level of support, financial support from the government. And the government itself want to absolve itself from responsibility to maintain this facility, but they do not want to commercialize it either because it can be scrutinized as a corruptions or bribery. But the community do not want to assume ownership, because if they assume the ownership, then they will be a full responsibility of the maintenance, which they do not believe they can handle themselves. So we also need to model the conflicting situations using the system dynamics. So as you can see that attractiveness is a stock. So it is just like a bathtub that you can fill with water. So the attractiveness can be added by the satisfaction rate of the people that is coming into the area. And then it also can be added by the quality of the hybrid facility, which is PLTH. And then it will also, the attractiveness will impact directly and positively to the arrival rate for the edutourism. And this will also create more problem or dilemma for the community, because as they can see that it is ever increasing the rate of arrival in their spot. But for edutourism, they see it as a more potential for commercializing the PLTH itself, so that they can maintain the facility themselves. So in conclusions, the data points out that the success factor of renewable energy implementations in rural tourism ecosystem comes down to financial support from government. So this is not entirely for ever, because the support will be needed until the community has established enough technical knowledge and also ready to pursue any means deemed necessary to sustain the maintenance process, uh, i.e. the commercializations of the PLDH for edutourism. And then the dilemma arose as government institutions will try to absolve itself from primary responsibility of the facility, while the community try to secure support until they are ready to maintain the facility themselves. And the model highlights the need for a regulatory basis that can support government institutions to be more flexible in collaborating with communities in favor of rural socio-economic development, particularly in regards to tourism and renewable energy. So that's it for our presentations. Thank you. I'm ready for any questions.
Okay, thank you very much for the presentations. Okay, we're getting less and less attendance today, but still, maybe there's any questions for this interesting topics on tourisms and renewable energy. Okay, so maybe from yeah, I have one question. It's like a very interesting study, but you have a specific site for your study, right? So I just wonder if we, since like in Indonesia we have a very diverse culture and probably like social perspective and others. Like, what do you think about the replicability for this research for the methods if we apply it to another area? Because this one is in Sumatra, in Palembang. What if we applied it like in Labuan Bajo, for example, or somewhere in the east? What will be the factors that we need to pay attention, or you think like the methodology can just like duplicate as it is? Okay, thank you.
Thank you. I want to clarify one thing. So for this one research, we do it in Bantul Regency in south of Yogyakarta. So we have two case study within the same area, and this is a rare and unique case because the place is supposed to be a national pilot project for renewable energy back in 2010, and we have both the successful and unsuccessful case of renewable energy facility maintenance. So the one in the Pantai Baru is the one that is successful. So it is almost 15 years now. And then for the Pantai Goa Cemara is the unsuccessful one. And that's why we can isolate that the financial support itself is the one main things that make them sustainable in a business sense, that they can still maintain the facility until now, because for Pantai Baru they have been helped with the financial support from public works department and energy department, because they have in Yogyakarta they have these two department combined within one department. And for Gua Cemara, they are assuming ownership right from day one, and they cannot maintain that. So if we are talking about the replicability of this case, I think other than the financial, the financial capability of the government to support, at least what they say is that around 3 years, when the knowledge transfers process happen, I think it's about the knowledge transfer itself, because the stakeholders in Pantai Baru said that they are, because this is a pilot project and their facility is pretty big compared to others, so they have like I think around 30 wind turbine, and then around several hundreds of PV. That's also create an attractiveness for students, from domestic students and even international students. So they are talking about students from France, from Germany, that also contributes to the knowledge transfers and how they can reverse engineers so that the facility itself can be maintained using local source. So that's also what it is, and also about the trust. So we need to also consider the trust among the local stakeholders, because the off-grid from the renewable energy cannot really supply for all the um, warung, or the food stalls within the beach area. So they have that limited amount of supply of electricity. So they have to do a lottery, a base of allocations. So that's how they maintain the trust between themselves to make the distributions of limited resource be justifiable.
Okay, thank you so much for the answer, and please give big applause for Mr. Rafi for the presentations. So, yeah, so we're coming to our last presenter. So the presentation supposed to be presented by Dr. Zikri Firmansyah, but he was here with us before, but he received sad news. There's his family members pass away, so he need to leave to the place. Yeah, to yeah, to the hospital right now. So today we will have Miss Anissa Noor, who will represent him to deliver the talks about the environmental social government ESG impact on corporate financial strategies of a global energy company. So please, Miss Anissa Noor.
Okay, good afternoon. My name is Anisha Nurfitri, representing Mr. Zikri Firman Sahakam PhD, and I will be presenting on environmental, social, and governance impact on corporate financial strategy of energy and utilities companies worldwide. About research publication update, the manuscript is currently under review at Energy Strategy Reviews Journal, a Scopus K1 index journal, and has undergone 9 rounds of rigorous review. We sincerely hope it will be published soon. Energy and utilities companies face escalating demand, environmental risk, and mounting ESG-driven investor and regulatory pressures, making ESG integration a strategic imperative. The amount of energy consumed has increased significantly, with oil, coal, and gas being the most common sources. By 2040, the U.S. Energy Information Administration predicts that the world's energy consumption will have increased by 28%. From 1980 to 2022, the consumption of electricity increased by over theirfold, coinciding with the global population nearing the 8 billion mark. And we see that before the industrial revolution, emissions were very low. Growth in emission was still relatively slow until the mid 20th century. In 1950, the world emitted 6 billion tons of carbon dioxide. ESG refers to the three central factors of measuring the impact of sustainability and ethics in making investment decisions: environmental, social, and governance. Constructing ESG scores is one of the important part in evaluating ESG practice implementation in companies. And there are three indicators for corporate financial strategy. The first one is financial performance, market valuation, and market risk. This literature review was conducted to compare previous studies, and this is research. We have reviewed at least 20 prior studies. And then existing research on ESG financial linkage offers mixed findings with limited sectors, specific insight for energy and utilities, highlighting a clear research gap. A quantitative approach using PLSM was applied to examine ESG influence on financial strategy in the energy and utility sector across global firms. There are two construct. The first one is theoretical framework and methodology for assessing ESG impact. And the study analyzes the impact of ESG factors on corporate financial strategy in the energy and utilities sector using a validated PLSM model. And the second one is about construct and variables for assessing ESG impact on financial strategy. And this study examines the influence of ESG performance on key financial outcomes. Financial performance is assessed using ROA and ROE, market risk through CAP in beta and Sharpe ratio, and market valuation via market value, logarithm, and price to close. And then there's two other model in this methodology. The first one is higher order model. The higher order model present ESG as a composite latent construct composed of environmental, social, and governance dimension. This model illustrated the main hypothesis, specifically its effect on financial performance, market valuation, and market risk. And the second one is lower order model. The lower order model disaggregates the ESG index into its three individual components to test their specific impacts on financial performance, market valuation, and market risk. And next, about the result and analysis. There are two result and analysis. The first one is higher order model will sample result. The higher model reveals that the composite ESG index has no significant impact on financial performance or market risk. However, it shows a strong and significant positive effect on a market valuation, indicating that ESG performance enhance firm value. Financial performance positively influence market valuation, while market risk negatively affects market valuation. These findings highlight ESG as a key valuation driver even if its immediate impact on profitability and risk limited. And the second one is about lower order model research, ESG dimension, and financial performance. And the analysis shows that only the environmental index has a statistically significant effect on financial performance, and the relationship is negative. This result suggests that short-term financial returns may decline due to environmental compliance cost or sustainability investment. However, previous studies indicate potential long-term gains, especially through improved emission efficiency. And the second is about the result ESG dimension and market valuation. The analysis shows that both the environmental index and the government index have a significant positive relationship with market valuation. The environmental index indicates that firms with strong environmental practices tend to receive higher market value. Similarly, the governance index reflects that strong management, shareholder rights, and CSR strategies contribute positively to investor confidence and valuation. And the third is about result and analysis ESG dimension and market risk. The result is revealed that environmental index has a significant negative relationship with market risk, including that indicating that firms with strong environmental practices such as resources efficiency, emission reduction, and innovation tend to experience lower volatility, and system risk. Meanwhile, the social index has no significant effect on market risk, suggesting its impact may be limited or indirect. In contrast, the government index shows a significant positive relationship with market risk, which may reflect intense where firms use CSR or governance disclosure to offset poor environmental or social performance, potentially increasing perceived risk. These findings highlight the nuanced risk implication of ESG dimension. And about the conclusion and recommendation, the key conclusion there is 3 points. The first one is market valuation. The ESG has a clear positive effect on firm valuation, reflecting investor confidence in sustainability and well-governed companies. And the second is financial performance. ESG doesn't show direct short-term impact. Environmental cost may reduce profitability initially, but long-term gains remain likely. And the third, market risk. ESG reduces risk primarily through environmental strategies, and however, certain governance-driven CSR effort may paradoxically increase perceived risk in controversial sectors. And about the strategic recommendation, for corporate strategy, prioritize environmental initiatives that enhance operational efficiency and long-term resilience, and enhance governance, transparency, and ESG strategy integration to strengthen valuation signal. And for policy and regulation, encourage standardized ESG disclosure through update reporting directives, and design incentive for firms that align sustainability with financial discipline. The limitation and the future research based on cross-sectional 2022 data, longitudinal studies needed for time-based insights, and cross-country sample may introduce regulatory bias, and disaggregating ESG further, for example, emission intensity versus energy efficiency, can reveal macro-level drivers of firm performance. And thank you. We sincerely thank you to the Asahi Glas Foundation for funding our research, and thank you for Direktorat Riset Inovasi ITB. Thank you. Arigato gozaimasu.
Okay, thank you very much. So, yeah, we have the message from Dr. Zikri that yeah, unfortunately he can present by himself, and if you have any questions, you can directly ask to him. Okay, so maybe this is the end of our presentation session today. So thank you very much, and I would like to return to Miss Ossie for the next closing.
Okay, thank you so much for Dr. Iriana. Wow, look at all these people, like standing by our sides until the end of the session. So, before we closed our event today, please join me in extending a warm welcome to Professor El Fahmi to deliver the closing address.
Well, very good afternoon, everyone. So finally, we reached the end of this seminars. I would say that it's very fruitful seminar, very nice seminar that we learn a lot from the 14 speaker. I saw that's a very prominent researcher at the ITB who already won the grant from the Asahi Glass Foundations last year. So we all of us already listened for the very nice presenters from very wide field of research, right? From the economic, from social, humaniora, from engineering, also from natural product. So we really have a very good meeting for today. So I'm also happy that all 14 recipients last year did a very good result, right? Although some of them are still writing the article for the output of the research, but some of them are really already have good performance. For example, they already have the publication, even not more than one, right? One published, one is still submitting, for example, and then we are really I believe that to come publication will come to us and then to improve our performance, the ITB level in this level. So again, I would like also appreciate for the all participant until the end of this session, right? But most of them are already gone because they are very busy, of course. But again, I appreciate for you still standing here. So this is really nice for us as well. Again, for the moderators, very nice moderators, of course, already lead this our second session, right, for the presentation. Again, I would like to, of course, would like to send my deepest appreciation to the Asahi Gas Foundation, who really have the big commitment to funds to give already 38 years, of course, and around 380 recipients. You can imagine how much the funding that they already gave it to us, of course, in order to increase our research performance, our research impactful, for example. And then we hope at the end, so maybe we can have also some product that has been started or from the Asahi research grant can be further continue with the other scheme, and then finally we have a really good result, not only about the publication but also can be used by the population, for example, also for the policy by the government, yeah, to be to make Indonesian into the what we call Indonesia emas 2045 gold Indonesians, what we call. So again, please send our greeting to the chairman and the Asahi chairman as well. So I think that's what I would like to say to you. I'm really happy today. This is also first time for me to lead this ceremony as well, right? So let we give the big applause to the Asahi Gas Foundation and our participant as well. So for the new recipients that will do the research in this year, of course, we will meet next year, right? With the very, I mean, better quality research, of course, if we compare with this year. Again, thank you very much for your attending today. So we are happy to have it together with you. See you next year in the same event. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Professor. So, ladies and gentlemen, that conclude our grand ceremony and seminar on research findings assisted by the Asahi Glass Foundation. Thank you so much for your attention. We will see each other again next year. So, mata rainen. Thank you so much and goodbye.